Good morning everyone. I am R. Vijay. I will be your host for today's session.
நான் உதயச்சந்திரிகா இந்நிகழ்ச்சியின் தொகுப்பாளர்.
I now request the director of CUIC to welcome the inaugural guests onto the stage.
Enjoy the next 30 minutes of uninterrupted listening.
I would like to thank IAS Innocent Divya ma'am, who is unable to join us today for the event. Instead of her, we'll be having Professor Gunasekharan on the stage with us. Good morning, ladies and gentlemen. A warm welcome to all the dignitaries, esteemed guests and faculty members. It's truly an honor to be a part of this prestigious event where innovation and technology converge for a better tomorrow.
அனைவருக்கும் எங்கள் பணிவான காலை வணக்கங்கள். தமிழுக்கு அமுதென்று பேர், அந்த தமிழின்ப தமிழெங்கள் உயிருக்கு நேர் என்ற பாரதிதாசன் வரிகளுக்கு இணங்க தமிழ் அன்னையை போற்றி இந்நிகழ்வினை தொடங்குவோம். அனைவரையும் தமிழ்தாய் வாழ்த்திற்கு எழுந்து நிற்குமாறு பணிவன்புடன் கேட்டுக்கொள்கிறோம்.
நீராறும் கடலொடுத்த நிலமடைந்த கெழிலொழுகும் சீராறும் வதனமென திகழ் பரத கண்டமிதில் தெக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழழகே உன் சீரலை திரும்பி அந்த செயல் மறந்து வாழ்த்ததுமே வாழ்த்ததுமே வாழ்த்ததுமே.
To commence today's proceedings on an auspicious note, we will now have the invocation and the lamp lighting ceremony. May I kindly invite our distinguished dignitaries on stage for the lighting of the lamp.
குத்துவிளக்கை ஏற்றி இந்நிகழ்வினை தொடங்க விருந்தினர்களை அன்போடு அழைக்கிறோம்.
Thank you, ma'am. Thank you, sir. Before we start the session for today, let's have a look at our agenda for the day. From 10 to 10:45, we'll be having the inaugural session. From 10:45 to 11 a.m., we'll be having an industrial keynote. And then later on, we'll be having solutions for civil engineering architecture by the NMHC group. We'll have a short break from 1:30 to 2:30 p.m. for lunch. Then we'll be having a panel discussion from 3 to 4 p.m. And we'll also be having our first panel discussion from 12:15 to 1:15. Then we'll be ending the program at 4 p.m. with a vote of thanks. Thank you. Now it's time to officially begin our inaugural session. We are privileged to have with us an esteemed lineup of speakers who are pioneers in their respective fields. Professor S. Kanmani is the head of the Civil Engineering Department at Anna University and holds a PhD, ME and BE from Anna University. She has received several awards including the Innovation Award and Tamil Nadu Scientist Award for her contributions to environmental engineering. May I now invite the head of the Department of Civil Engineering, Professor Dr. S. Kanmani, to deliver the welcome address.
இந்நிகழ்வின் முதல் உரையாக வரவேற்புரை ஆற்ற புரொஃபசர் டாக்டர் எஸ் கண்மணி துறை தலைவர் கட்டுமான பொறியியல் துறை அவர்களை பணிவுடன் அழைக்கிறோம்.
Thank you so much. Very good morning, one and all present here. It gives me immense pleasure to welcome this August gathering for this one-day program titled Empowering Next Generation Engineers and Architects. At first, I wanted to express our sincere thanks, heartfelt thanks and gratitude to the NMHC Managing Director, Mr. Nirmalya Chatterjee and his team, especially Deepankar Bhattacharya sir, for taking this initiative to sign this MOU, prestigious MOU, and with Anna University for the Department of Civil Engineering, and especially to train our civil engineering students and with respect to the advanced software technologies for building designs. Thank you so much, sir. And also we are very happy to welcome you and we very much value your precious time, your time and your team members, and thank you. So a very warm welcome to you, sir. And I'm so happy to welcome and my senior and our professor ma'am, Professor Usha ma'am. So happy ma'am and to welcome you for this, and so your gracious presence is very much valued. And I'm very happy to welcome Mr. Sendilagan sir, and so he is our alumni and bachelor's degree in civil engineering in College of Engineering Gindi and 1 year senior to me. So happy to welcome you, sir, and for the second program in the past 2 weeks, and so that shows that how much you are attached, having got affection towards Department of Civil Engineering. I'm also very happy to welcome our director and CUIC, Dr. Shanmu Sundaram, and Deepankar Bhattacharya sir was telling to me that Shanmu sir is so close to me, and I'm so close, my heart so close to him. It is the same feelings with respect to myself also. So happy to see and your growth and your contribution and your remarkable journey, and especially to Anna University. And I very much wish you all the very best, and happy to welcome the Director CUIC. And of course, I'm happy to welcome our Planning and Development Professor representing Innocent Divya ma'am, IAS. And so happy welcome Professor Gunashekaran sir. And my heart felt welcomes to former head of the department and Dr. KP Jaya, and who is instrumental in bringing up this MOU to College of Engineering India and for the benefit of all civil engineering students, not only to CG campus but also making it wider to all the Anna University affiliated colleges also. Happy welcome to Dr. KP Jaya and all the professors in the the Department of Civil Engineering, and also a heartfelt welcome goes to our friend and my senior and Dr. Ravi Kumar, former registrar. Welcome you, sir, and also deputy directors and the staff of CUIC for making this excellent arrangements, and every one of you, all the dear students and faculty from different colleges, and so far are spending your valuable time here, and so welcoming you all. Thank you so much.
Thank you. Thank you, ma'am, for that very warm welcome. Next, Dr. K. Shanmugasundaram is a director of CUIC and a professor of mechanical engineering at Anna University. He received his PhD from Anna University and has been honored with several awards, including the Best Paper Award on Heat Treatment and Surface Treatment. So to set the context for today's event, may I invite Professor Dr. K. Shanmugasundaram, Director, CUIC, Anna University, to share his thoughts.
அடுத்ததாக CUIC இயக்குனர் ப்ரொஃபசர் டாக்டர் கே சண்முகசுந்தரம் அவர்களை கருத்துரையாற்ற அன்புடன் அழைக்கிறோம்.
A very good morning and a warm welcome to each and everyone present here on behalf of Team CUIC. Most respected and distinguished chief guest of the day, Madam Innocent Divya in absentia for our sudden setback in the... Oh, please. Hope she is fine. Right, okay. So for a sudden setback, she could not make up to the event. Distinguished alumni, proud contributor to L&T as Executive Vice President, Mr. K. Sendilnathan. Our co-host of this event, the torchbearer of beam technology from Nemishek, the Managing Director and Vice President, Mr. Nirmalya Chatterjee. Our Senior Professor representing Anna University, Professor Usa. Head of the Department of Civil Engineering, Professor Kanmani Madam. Respected friend and Planning and Development Director, Professor Gunashekaran. Former Registrar, Professor Ravi Kumar, former Dean, Professor Shekhar, dear colleagues from Civil Engineering Department, respected invitees who have registered, all press and media who have responded to the call, and one and all present here. A very good morning. At the outset, when the discussion of having skills came up, probably last 3 years, this has been one of the most abused words. We were able to see every bureaucrat talking about skill, every corner of politicians coming out with saying that skill in India is lacking and our engineering students are no way related or relevant to the industry, except for the academicians. And it is at that point of time when a compulsion from the present government to introduce the skill development courses through a program called Nan Mudalvan was introduced. Even then, we were able to identify the missing relevant skills that the industry were expecting and unfortunately were not included in the syllabus or could not be augmented immediately, were given by the government as the skill development courses, but the success of it cannot be continued only by the government. So it becomes the responsibility of the university, it becomes the responsibility of the respective departments to augment the students with the relevant skills. And that's where, for civil engineering, when we have the greatest strength of having the largest department known to the entire state of Tamil Nadu, be it from soil mechanics to structural engineering to water resources to remote sensing to environmental science, anything that you name it, we have great experts. But if we all go and meet our industry, still there is apprehension that the latest technologies like BIM is not too known by the students to the level which the students can directly work on if they are hired. So this building information modeling, probably for the people who have been registered and walked in, if I have to relate as a mechanical engineer, if there is going to be a design for a new product, naturally we keep that life cycle in mind, have the basic developments, and probably the regular periodic maintenance, preventive maintenance, everything comes into play. But identically, if I could relate to civil engineering, for the past 1 year and 2-3 months, we could see the doom of the main building, once hit by the lightning, is getting ready. So the data or the information about that building, if it had been available, if at all, if there is going to be a thought process that it has to be prevented from certain setbacks by having certain maintenance at a certain point of time. All these data are going to be not available, and when we see conventional office files and people working on them getting transferred, as we could see, taking 18 months of time to repair a particular dome of heritage building is for what reason? So if it has been understood, this word BIM is not new. It has been from the 1970s, and by the time 2000, ISO standards have come. And by 2010, China has extensively used it, and they have their own research publications saying that at least 20% of time and 20% of cost, which are the fourth dimension and fifth dimension of the existing 3D models, of all the digital models that they have grown in just last 30-40 years. So when India is seeing as almost at the pinnacle of having a reformative growth, specifically in urban infrastructure, where railways, transportation, all the other buildings shifting from the main urban areas to rural areas, then naturally men may come and men may go. But today the digital technology is there and a lot of huge, humongous data. So if our students are going to completely understand and try to use these kind of softwares, and that is where this thought process ably resounded by my dear friend Mr. Dipankar Bhattacharya, who just took up this new role, met us way back in November last year, had a willingness to be an intellectual partner, provide a center of excellence, train our faculty, give a specific training on this specific tool of BIM, where this German company having their Indian office have already made similar arrangements with 3 more universities in India. We were very happy about it. And that's where the former head of the department, Madam Jaya, was quite proactive. Though this architectural engineering and construction industry has been growing at a rate of 6% every year, the students that take up this course is quite disheartening to note over the years. And in fact, when the discussion I had with the chief guest, Mr. Senthilnathan, how this can be translated, we could see even the interest of the people. To be honest, for the information of the members who have responded, we had 285 registrations. And only when you are going to have that translated as physical presence, understand the importance, and transferred to the general public, be it the parents or the future generations who are going to take up this, there is going to be crucial shortage of manpower. And that is where I am quite happy, and I express my sincere thanks to the entire team of NEMISHEC, Mr. Nirmalya Chatterjee, Mr. Dipankar and team for having shown interest, and we are at the pinnacle of signing this MOU and exchanging this MOU today, and thereafter we are going to have entire brainstorming sessions where our alumnus, Mr. Ranjit Kovilankal, is going to moderate and have a panel discussion with leading industrial experts, and we are going to have the entire industrial scenario by our chief guest, as well as the case studies by the NEMISHEC team, and end the day with one beautiful role of what industry and academia and how we can interact. And in that, we have our fond former professor and registrar as well as dean, Professor Rani Vedamuthu, moderating a session. So in short, you are going to have a brainstorming day, a very enthusiastic day of learning, because as a mechanical engineer, we see what are the ways in which we can always enable our students so that they become relevant to the mechanical industry, which is growing at 10 to 11% annually. And when we see sustainability, cost, and your time is going to be the fourth, fifth, and sixth dimensions for the 3D models of all the buildings that are already in existence, and to be honest, including the digital twins is what we are talking about. And even civil engineers are going to see digital twins, which is a kind of phenomena that we have been hearing about by the product developers from the IT industry. So this is where our importance of understanding, appreciating, and learning this particular software comes into. So at the end of my talk, I once again thank the entire team of NEMISHEC with Nirmalya Chatterjee, the MD, leading it, and for all the people, once again a warm welcome. Thank you again. Thank you.
Thank you, sir, for that insightful and detailed description, which laid the foundation for today's sessions. Nirmalya Chatterjee, MBA in Sales and Marketing in Civil Engineering, is a seasoned leader in the AEC sector. Currently, he serves as the country's VP and MD for NEMISHEC Group, driving digital transformation through BIM solutions in India. I now request Mr. Nirmalya Chatterjee, Managing Director, NEMISHEC India, to share his vision on technology and innovation.
NEMISHEC இந்தியாவின் நிர்வாக இயக்குனர் திரு நிர்மல்யா சாட்டர்ஜி அவர்களை உரையாற்ற அன்புடன் அழைக்கிறோம்.
Thank you. Good morning, everyone. I'm really very thankful for having this opportunity, particularly individually on myself. I was little nervous when I was entering this Anna University. This is my first time I entered Anna University. I heard about it. My daughter has passed out from Chennai itself, but not from Anna University. But Anna University is the one which is one of the oldest in India. Wherever we were students also, we were all getting this reference of Anna University. Anna University is like a kind of a benchmark throughout, not only in India, probably globally also. So that is why I was a little nervous. I've been presenting things to any of those conferences. I never get that kind of a confusion or a kind of losing the confidence. I need to confess that today I'm not the same because I'm sitting and I'm standing in front of all the teachers. So this gives me my engineering days back, how we used to face those teachers And, when I recalling that, it looks like I'm the students here, and I'm facing those teachers. So obviously, a student will be always going to be fearful when they're going to face the teacher. So with that respect to all of you, I also humbly thankful to the group who has been involved in this session, in this initiative. My colleagues, Dipankar has been proactively working, and he has been referring to me that we must do it in Anna University on priority basis, because that's the hub, that's the technological hub that we must encourage on that. And the reason we are so much focusing onto this students community enhancement goes into two folds. First, we are the one who is a technology company. We innovate, we develop technologies for the construction, for the architects, for the engineers community. Now, obviously, as a commercial company, we have our own interest, how we sell software, how we make sure that this been implemented by companies like L&T or any other companies. But the other hand is that software, we also know that software itself cannot work. It needs an engineering hand behind it. And until and unless the engineers who's passed out, if they are not able to equip with, then it is not going to be full-fledged implementation. The second part, which is my personal belief, and that we do have a very good education system in India. Our curriculums are very good. We are in theoretically is probably the best. But when it comes to the employability of those engineering students, particularly to the civil engineering or the architectural engineering, we see there is a gap. If you have to compare with computer science, if you have to compare with any other engineering disciplines, probably the civil engineering or architectural engineering is not getting that much of the credit from the industry. The reason behind being that the not being into the par of the industry demand. For a company like L&T, will always going to recruit new fresher engineers who's going to have the know-how of technology which can be immediately a productive guy. And that's where we found there is a gap, that how we can fulfill that gap and how we can contribute to this as a technology company. And this is where we comes in. And the last part, and about this Anna University, I was having a lunch meeting yesterday with the Honorable Minister PTR, the IT and Digital Minister for Tamil Nadu, and he was accompanied by Mayor and also the Chief Secretary of the IT. And I was briefing about all our companies and other initiatives. And suddenly the Chief Secretary was telling me, hey, why you are not investing or doing something for the Anna University? And I said, sir, your words is your command. Tomorrow we are going to do that. And he was very happy, and then I realized that he is also an alumni of Anna University. So it's all connecting together, and our efforts is hopefully going to take a good step in the coming days. So I'll take a couple of minutes to talk about it, what we are and what we are going to do, what in the future, what is our aims. So these are the industry's challenge, the construction industry's challenge. This industry is facing hugely setback because of this challenge. Whether it's a time, you were referred to earlier, that this time and the cost is the factor. Yes, it is the factor. Then the factors of the global carbon kind of an emission. Construction is contributing hugely into that. Our Honorable Prime Minister always talks about it, that how the environment-friendly things can happen. So definitely construction industry has some role to play into that direction. The aging factors, that the old assets, this is like a 30 years, 40 years, 50 years back, which has been prepared. Now how that could be maintained further, how it can be make sure that these assets remain for another 40 or 50 years. That is another challenge the civil engineers community is going to face. The other aspects is the wastage of the raw material. All of you, the civil engineers, will be always agreeing that in the construction site, we get a lot of wastage of the construction materials. And that wastage again contributes towards the environment aspect. How we can make sure that we do accurately so that the wastage of the construction things are reduced. And the last piece, which is our very close, which is the resource crunch into the AEC. When you say AEC, it is architectural, engineering, and construction. And we believe, and strongly we have seen the data, that not enough good resources are available in the industry in that space. And that is the reason behind Nemetschek is taking this initiative to make sure that we address all those challenges areas. Now, we as a technology company also make investment into AI. All of you might have already been heard about it, that every technology company is talking about AI. What is the difference between all other technology companies and ours is we believe strongly in the ethical way of use of AI. We have, all of us, experienced and seen that the social media or those aspects where the bad side of the AI, so we have to make sure that when we are implementing AI, it has to be in an ethical frame. So our AI is always making sure that it is coming as an assistance for a speedy way of executing the job, but we are not giving a kind of full autonomy into this AI within our platform so that it is becoming a more restricted use and it is on the ethical way part of the usage within that. So we call it as a generative design AI, where the AI can be used more for the facilitations of a better design aspect, which is going to help executing the job much more faster and smoother. Little bit about our company. We are a German-based company. We are already having more than 7 million users globally, more than 4,000 our employees globally there. We are near about $1 billion right now, and we are growing in a very exponential way of double-digit part of it. What quickly I'm going to touch upon about the entire workflow, because we are here to gather all the civil engineers, professor and the students, so you will probably be able to relate here that from architectural to the construction, this entire workflow needs to be addressed by a different solution. So what Nemetschek does is as a bundle of solution which connects each segment. So it is not as a silos that a civil engineer is going to work. The architect also needs to work on the same phrase. The same way the construction management guy is also going to work on the same. So that is the kind of a workflow that Nemetschek works, and to address the entire construction part of it. And we will make implementation of this center of excellence here, this civil part of it and the architectural part of it, so that the students can learn the entire workflow of the execution. These are some of the solution stacks I would like to quickly run upon, and I wanted to emphasize that what as a center of excellence from the Nemetschek, that Anna University's students are going to learn. They're going to get this entire stack of the solution from Nemetschek, and we're going to implement, we're going to train your students, train the faculty members to make sure that this latest technology of the globally accepted technology is getting a know-how of the students community, and they are able to adopt, and they're going to be employed by these global companies. So these are the few reference companies that already an user in India and globally. We can also make sure that the placement part from the Anna University students can also reach to those commercial companies with our help. So that they knows that, okay, these are the students, fourth year, final year students. They have learned these solutions, they got a certification, and those commercial companies can then consider, especially for those campus recruitment part of it. As I said, that we are doing it as the fourth one. We have already done the JJ College of Architect in Mumbai. We have also signed an MOU with AKTU, the Lucknow University, VTU, also in Bangalore, and we are working very closely with AICTE chairman to make sure that from a central level, the education curriculum part also gets implemented and gets revised little bit, where the adoption of good technology being a part of the students' community. Until and unless we reach to that stage, probably it is not going to be much successful on that. So that's how we are aiming to do in that direction. We will be also making this NEMICHEC Center of Excellence here in Anna University much more successful way. At the end, I'm just going to run a very quick video for all of you to know that where we stand in India, because we are a global company, but in India, we have just started 1 year back. So, see that video. With that note, I thank all of you for being present here, and I'm looking forward to participate, involve in this today's session. Thank you very much, everyone. Thank you.
Thank you, sir, for that insightful presentation about NEMICHEC Group. It's a pleasure to host you for today's session. Now we will witness a significant milestone, the exchange of the Memorandum of Understanding between Anna University and NEMICHEC India. This collaboration marks the beginning of a new era in academia-industry relations. We invite Professor Jaya, Head of Structural Engineering Division, Professor Gunashekaran, Director of Planning and Development, and Mr. Deepankar Bhattacharya, General Manager, NEMICHEC Group, India, to be a part of this momentous occasion. Let's have a big round of applause. Thank you everyone. Will develop talent for the AEC industry and shall equip the students with the latest tools and technologies in the field to enhance their employability. I now invite Professor Gunasegaran on the dais to share his thoughts.
Good morning, dignitaries on the dais and off the dais. I am really happy as a civil engineering professor that AEC, which we call Architect Engineering Construction and Operation, is going for the next stage, that is the digital age. And I am really thankful for the NextGen company who has sponsored the Center of Excellence in BIM. And our students will be getting an exposure in the BIM and they will be applying for all the projects, not only at Anna University and also for the great projects they are involved with. So normally when we take a building construction, I was also the estate officer. So I know the difficulties in understanding the way in which things take shape. So when we start building that, we think we have the money and we want to do something, we start with some project. The plan may be at a concept stage, then we take it for approval with the rough estimate. Once everything is approved, then we start with the design, the detailing, estimation, tendering, and finally transferring to the field. So when we are involved in all the stages, when there is some change in the design or concept, the flow may get affected if the information doesn't pass through down the line. So here the BIM will help our students to understand how the flow has to take from the planning stage to the architect, the structural designer, detailing team, the estimation, and for the owner, so that everyone is in the same line of thought and the whole idea is transferred to the field to everyone's expectation. So it was a dream for all our civil engineering professors that we should also get trained and our students should also get trained. I think it is a great effort by our professors, our HOD and Dr. Jaya and from the NextGen team and from L&T Vice President, that this facility has come to Anna University as a center of excellence. So our students' experience and exposure will be gradually a great change. I think from next year onwards, all the buildings at Anna University will be modeled using this concept, and I think the team will also be facilitating that thoughts. Thanks for the entire team. I think the highlight of the success of this Center of Excellence can be explained from the words of Professor Usha Madam. So Madam has expressed, I was an electrical engineer. So if I was a civil engineer, I think I would have loved to see all this on the field. So Madam was really happy. So I'm just conveying the thoughts of her. So I wish all the best for the entire team and see that many more Center of Excellence comes for the civil department. Thank you all.
Thank you, sir, for sharing your thoughts with us. I now invite Mr. Nirmalya Chatterjee to speak a few words about the MOU exchange.
I actually already shared my thoughts on this part of it, but yes, I can repeat one more time that how excited we are from a company side with the association with Anna University. There is no doubt in our mind that this Center of Excellence will create great examples, and probably it is going to create some sort of trendsetter for the other universities in India based on the success that this Anna University students is going to learn from this Center of Excellence. I'm so happy, I'm so honored to be a part of this MOU sign agreement, and I look forward for this whole day session today. Thank you very much.
Thank you, sir. I now would like to invite Mr. Nirmalya Chatterjee to present the guests with a bouquet and honor them with a memento. Let's have a big round of applause. Thank you, sir. Let's welcome Professor Dr. K. Shanmugasundaram, sir, to present the memento to Mr. Nirmala Chatterjee. Thank you, sir. To conclude our inaugural session, let us express our gratitude to the vote of thanks by Mr. Deepankar Bhattacharya, General Manager, NextGen Group. Welcome on the stage, sir. Let's have a big round of applause.
துவக்க விழாவின் நிறைவாக நன்றியுரையை ஆற்ற திரு திவாங்கர் பட்டாச்சாரியா பொது மேலாளர் நெமச்சி குரூப் அவர்களை அன்புடன் மேடைக்கு அழைக்கிறோம்.
Good morning. First of all, it's my privilege to propose the vote of thanks for today's inaugural session of this seminar titled Empowering Next Generation Engineers and Architects and the MOU exchange between Anna and NextGen. First of all, I would like to thank our chief guest, Tirumati. Yesterday was supposed to be here, but due to her ill health, she could not make it. But in absentia, I would like to thank her. And I am hoping that she will be available when we actually open the Center of Excellence in Civil Engineering in less than a month's time to inaugurate the Center of Excellence. So thank you very much, madam. I would like to next thank our keynote speaker who will be immediately presenting after the inaugural session, Mr. K. Senthilnathan, who is the Executive Vice President of Larsen & Toubro. Next, I would like to thank Madam Usha, who is the professor in electrical engineering and also the member of the governing council of Anna University in the absence of a regular vice chancellor. So thank you, ma'am. I know it was quite a tight schedule for you, but thank you, ma'am, for making it to this inaugural session. Next, I would like to thank Professor S. Kanmani, the HOD of Civil Engineering, who has been instrumental and the guiding force in ensuring that we exchange and sign this MOU today. Thank you very much, ma'am. I would also like to thank my dear friend, Professor Shanmugasundaram, whom I know for more than a decade and have had lots of ups and downs during my interactions, mostly ups with him. And but I think without his intervention and without his proactiveness, this MOU would not have been approved by the syndicate. I think these MOUs take normally 2 to 3 years for approval, okay? And I think this MOU, when he called me maybe in less than 2 months that the MOU is approved by the syndicate, I asked him twice, are you sure? And then immediately he forwarded me the copy of the, the approval from the syndicate. So thank you very much for ensuring that we signed this MOU at such a short notice. I would also like to thank Professor Gunashekaran, the Director of Planning and Development, who is the key part of the MOU approval committee, who has also played a vital role in approving in getting this MOU through. I would also like to thank there is a formal vote of thanks at the end of the session, but I just wanted to thank two people who has made this possible, Professor Jaya, the HOD of Structural Engineering and the former HOD of Civil Engineering, and also Shibu, the Deputy Director of CUIC, without whose support, without his training to these brilliant students, this event would not have been possible. And last but not the least, my colleague Gayatri for doing a flawless execution of the event. So I leave it at that. I should leave something for the formal vote of thanks at the end of the day today. Thank you very much, and wishing you the best for the session today. Thank you. Sorry, I missed to thank Mr. Nirmala Chatterjee. So I would like to thank, it was not intentional, but it just skipped my mind. I would like to thank our MD and Vice President from Nemetschek India Group for having graced the occasion. In spite, he travels almost, I think, 15 days a month, but in spite of that, I was able to pull him and spend a day right here at Anna University. Thank you, and we call him, popularly is known as NC, so thank you, NC.
Thank you, sir, for ending the inaugural session with grace. Now we move on to our first panel discussion, and Moving on, we have the stage for our industry keynote session, where we explore the theme, leveraging technology and embracing future trends. To deliver this keynote, we are honored to have with
the co-host for today's session. Mr. Senthilnathan K. is the Executive Vice President and Head of Technical Services at Larsen & Toubro, specializing in design, construction methods and procurement. A civil engineering graduate from College of Engineering, Guindy, he brings extensive expertise in project management and technical services. With over 1.5 years at Larsen & Toubro, he plays a key role in driving operational excellence and innovation. We welcome you, sir.
While they are clearing their dice, I would like to thank the organizers for inviting me to give the keynote address. And as Mr. Chatterjee said, talking in front of professors is very difficult. So I thought I can make a presentation. And whatever flaws or whatever mistakes I have done, my professor, definitely Professor Shekhar, should accept, and it's all because of him. He took 2 semesters of structural steel design. So 90% of my tenure, I have only done steel design. So anyway, thanks, Professor, and my dear friend Ravi Kumar is my classmate, and he also knows I am not a very excellent student, but I am a above average student. I didn't get the gold medal. That's what I landed in L&T. Otherwise, I'd have gone elsewhere and doing something else. But nevertheless, it's a long journey. I'm completing 38 years of service. I have not learned anything out of this college. So whatever I have done, it's only because of this college and the professors. I am very happy that Anna University has taken a step forward, and not only forward, a leap step forward, have joining hands with Nemetschek and what is the need of the hour. And in my presentation, I'll show, though we talk about more negative about civil engineers, what are the things we have done in India? Because I don't want to get into international. I want to tell or show what we have done in recent past in India and which made our nation proud. And also I'll touch upon what, as an industry, what we are looking for. Since most of them are faculty members, it will be an eye-opener or from our side what we are looking. But we are not industry. As L&T construction, you know, we grow year on year at least 10 to 12%. So we train people. We don't look back and blame institute. We know the difficulty of institutes, what they have. So for our growth and our business, we train people what is required for growth and business. So most of the things what Nemetschek had said, like BIM and other things, to some extent we are also trained people, and we train graduate engineers, diploma holders, even some places where IIT people are also trained, and depending on the requirements. And what other initiatives as an industry has taken to make the civil engineering proud, I'll just show you. So my title is Leveraging Technology and Embracing Future Trends. My content, I'll run through some of the key projects recently what we have completed. And I'm very happy Nemetschek has shown one of the beautiful bridge what I myself have designed using BIM. So I'm very happy that Nemetschek has taken that one. I'll show that also here. So these are the 4 projects I'll highlight. Then technology initiatives and focus in progress what we have taken. Some of the future technologies what the industry feels it may happen in civil engineering. And some of the key takeaways what we should do and how to go about. To start with the one of the beautiful bridges which we built in Mumbai. It's called Mumbai Trans-Harbour Link. It's, as you can see, this is the 12th longest sea bridge in the world. Of course, it was inaugurated in January 2024. We started in year 2017, 2018. In spite of pandemic, we were able to complete in about 7 years' time. The normal time given was about 5 years. If you leave alone the pandemic, definitely we have completed in about 5 years. So it's the feather in our civil engineers cap that yes, we have done something marvelous. So getting into this bridge a little bit, it's connecting Mumbai mainland and the Mumbai island, what they call. It's totally about 32 kilometers. Out of that, L&T did the part of it about 10 kilometers in the sea. Of course, the Indian engineers did the execution, but we didn't have the technical know-how, but we joined with companies like CUIC, Sistra, IHI. IHI is from Japan. And it's a unique design. And because you can see there are some markings what I have made, OSD 1, OSD 2, 3 and 4. Here, because flamingos comes during some season, so they didn't want to have any cable stay bridge or any suspension bridge, so they didn't want any cables to be hanging because the birds will come and hit and get killed. So they wanted to have a steel design. It's an orthotropic steel deck, what we went about it. It's about this all 3, OSD 1, orthotropic steel deck 1, 2 and 3 and 4. Overall in L&T scope it's about 40,000 metric ton. It's a unique design. That's what we went for IHI Japan who had experience. They had a design experience. Of course, the execution part, it was given to L&T. And we had come out with how this OSD, these steel decks about weighing up to 2,500 can be erected in the middle of the sea. So we did an analysis on construction part and we came out with how we can optimize. As you all know, in India, unless otherwise the lowest bidder, you will not get a project. So we have to bid before, be a lowest bidder, and out of that you have to make some profit here and there. We normally make about 3-4% margin. That's fine for a construction company, but we have to make it. So after bidding, then we have to optimize on the steel design, steel structure, and we applied our construction methods or construction scheme and optimized the methodology, how erection cannot be done as a full continuous beam, then during construction, how it can be converted or it can be brought into a continuous beams, this thing, and we have arrived at the solution. So these are the various activities, what it has to be done. And we had to do a lot of temporary works. You can see on the right-hand side, or your right-hand side, third one, we had to do a lot of temporary piles and other things. The deck has to be done, and how to take this barge into this thing. So to cover all these things, I have a small video which tells how did we go about the erection of this orthotropic steel deck. See, why I've shown this one, this is all basic things what we have learnt in college and we have implemented. We have done from soil mechanics and structural steel design, analysis, everything. So you have to instill the students a confidence. Because this job was assigned to me as a task force leader to come out with the temporary works. And the cost L&T invested on this almost about 300 crores. But when you take a challenge of 300 crores, it's not easy. So you should have the confidence to do it. And after completion, one of the consultants asked, if this would have failed, what was the alternate option? I said, luckily you didn't ask before when I started. I never had a doubt that I will fail in this one. Because I am going to invest 300 crores, but that was this one. So students, you teach them, tell them that you have to have confidence what you have learned and you can implement. If you are thorough in your subject. Thanks to Professor Shekhar, I have done most of the design, sir. Now, second project is the coastal road. You would have seen, this was the first coastal road project in India. And what we did here is the project is along the coastline. There are a total length about, if you add everything, about 7 kilometers, which we did. It was all divided into 3 packages. We did the first and the fourth package. In between packages, other contractor did. But when we took the job, we had a challenge. I'll just go to that one. Because of the fishermen and environment, the left side, the client wanted the pile cap to be done at the ground level. They don't want any pile to be projecting above the water level. And the next to this project only, the Bandra Worli Sea Link, there also client wanted the pile caps to be at the bed level. And the contractor took almost about 10 years to complete that bridge because about 6 years they struggled to do this pile cap under the seabed. So what we did, we didn't want to go and do that one, and we came out a proposal having a large diameter pile. That was the first time in India, and we searched around, and when in profession, copying is not bad. So there were some large diameter piles were done elsewhere. And when I was in Riyadh Metro, the Samsung, another JV partner who had done a 3-meter monopile, which I have seen. So now I came back, I thought, yes, we also should do it. And we started from the design. Our codes does not permit monopiles. So we had to refer a lot of international codes and how to modify it. And the client had a technical team from IIT Madras, IIT Mumbai, IIT Delhi, and some professors from IIT Gandhinagar, geotechnical professors. So it was pool of professors. They analyzed our design. It took time, about 3.5-4 months time to get the drawings approved, but finally we achieved it and we have completed the project. If it not have happened, still this project would not have completed because it's a challenge. So you have to give the hope and how to read international codes, compare with Indian codes. There are limitations on Indian codes, but you have to tell what are the limitations. It's a code is a guideline, it's not a Bible. I used to tell to my engineers, it's only a guideline. You follow the guideline and you take a decision on the codes. So you can refer international codes and you can complete the project like this. So we have brought in some technology like this also to India. And this is going to be adapted elsewhere in all the projects in future. The third project, of course, Nemichek. Thanks, NC. You had shown this beautiful bridge in your presentation. I'm very happy. This was an extra dose bridge, the longest concrete segmental bridge in the world. And if you happen to go to Hyderabad, you will not miss this bridge anytime. So here also the client wanted a beautiful bridge across a lake. It's not a river or something, it's across a lake. And we had difficulty on either spans, either ends. Normally we prefer to have at least a 50% of the span length on the balance part, rear part. So it was not available. In spite of that, we tried to go and tell him it's difficult, all these things, and there's a curved also rear side. But client said nothing doing, this is the proposal, I got approval from the chief minister, so nothing can be done. Like this only, something like this they have shown, but we have to come. And here also it was very, very small bridge for an international consultant to come and do a design because they are charging FTE fees. So I went to our management, I said, we'll try with in-house design. And we started doing the design, segmental, concrete bridge, extra dose bridge, longest in the world. You know it's very difficult. NC will understand when you go and tell something we are going to do no to the management. They'll say, look at it and say, get out of this room. Don't talk all these things because we are here to do business, not to create monuments. But I convinced our management and we did. So it's only a mindset what we should have, how to convince. The convincing power you have to instill in the college itself something they wanted. Nowadays, before asking itself, parents will give. You should tell the parents, don't give, let him come and convince why he needs. So he'll get that confidence to go and convince anybody. So this is the bridge what we did. Because of the balance part, we had a shorter length on the rear side. So we didn't change the outer shape. What we have modified the thickness, and we were able to achieve the structural stability what was required. So the construction challenges it had, so we have overcome all the construction challenges, and now it's a beautiful bridge in Hyderabad. I'll just run. This is not a rendered one, it's actual bridge. There, even the lighting, the structural engineer coordinated with the electrical people and came out with the lighting. During Independence Day and Republic Day, the national flag will be there at the center, and the color will be, the national flag color will be there. So it's only, people have to be coordinating with multidisciplinary, it's a need of the hour. It's not only core civil engineering is not sufficient. So they have to discuss with other people also, like MEP and electrical works are important for a bridge also. The next one, this is the talk of the town, the first bullet train. So I'll just briefly explain about this one. And this is a total length about 508 kilometers. The first package was awarded to L&T. We also won after bidding about 233 kilometers. So I'll mainly talk about that 233 kilometers, how we went about it. So it's about 233 kilometers. We had tunnels of about 0.35 kilometers, small tunnels. And we had 4 stations in together, and other things are, other facilities what is required. So we need to mobilize about 2,000 staff for this job. And you can see what are the other things what we have done. Everything is mammoth. And because it has to be completed in about 4.5 years, what was the original time. And it was driven from top, from PMO's office. So we had to mobilize. And we can't, this equipment, this is the first time what we are doing at high-speed rail, and we can't get everything from overseas and other things. That will not give the cost or cost benefit to our company. So we went about again, what we did, all these tackles what is required for the erection, because design was given by them. So, the piles were supposed to be designed by the contractor, and for this 233 kilometers, there were about 34,000 piles, almost about 1 million running meters of piles. So they are given very strict specifications that you have to do soil investigation at the pier location and arrive at the piles. So we had set up one of the biggest soil testing lab at site. That's you can say your right corner, this thing, about 56,000 square feet lab we have established. Not only that, whatever other things, what is required for the straddle carrier, how to erect, all these things. Anyway, I'll show all this equipment, how it has been used in the next video. So this also was designed within 6 months and fabricated in India in about 12 months. All this were put from the starting date, 18th month, all these equipments were at site. So this shows So for that one, we have extensively used BIM. All were done in BIM because we had to fabricate. Like that one set I had shown, we had implemented about 14 sets at the site. So everything to be fabricated. So we did the BIM, including the fabrication drawings were done through BIM, and it was given to the fabricator. So it was fabricated across India. So they could arrive, get the BIM model, and they were able to do the fabrication without any problem. So coming to the next one, the new technology what we have taken. We have taken about 12, 13 new technologies what is required for the construction field, especially on infrastructure. So I'll just run through a few of them. The first one is, as everybody knows, we have started with manual, then mechanization, then automation. Now we are looking at robotics. And since we don't get enough skilled labor, and we can't blame them because they have other opportunities in their life. So how to go about the construction, we are looking at the robotics. Already we have put about 4 robots in our C4, that high-speed rail, where it's tying the reinforcement. So we wanted to extend that robots, and we want to use them extensively in our field. So the students who are coming out, they should know a little bit of mechatronics and robotics, at least some classes they should undergo. So when they wanted some need, because they have to tell, because IT people, other people may not know what sort of robots you required, so only civil engineers can explain. So if they know a little bit of their language, they can talk properly. So second one, you would have seen a lot of accidents happening in the erection part. So what we did, without any manual intervention, we went the civil engineer designed that one and interacted with the mechatronics fellow and come out with the remote operations, this one. It has sensors, so no labor need to go to pick up a segment or erect the segment. So this was an invention done by a maybe about 4 years old engineer who is working with us. He has come out. Next one is to activate the speed of the activities in the, especially metros. We want to go in for a precast segmental pier. Indian code has some stipulations for the seismic activity and the detailing part. So we are trying to do some model test and do the testing in IIT Madras lab and arrive at or define what should be written in the code. So it is going to be a challenge, and we had interacted with international professors. Last time, one of the professors who had come for ACC Trichy, he had done this accelerated bridge construction in California. So I had interacted, then we had a couple of meetings with him, and he said how to go about and how we can incorporate this specification in your codes. So people have to have that sort of mindset or open-minded to go out and define. As I said before, the codes are guidelines. It is not a Bible. So we have to take it up and take it seriously and go about it. And another one is ultra-high performance concrete. I know most of the universities would have tried the testing. Now how to implement it practically. Because whatever we say, whatever we had seen, there's only some, we have to, after mixing with us, we put in 20 minutes or 30 minutes what they are telling, it is not going to work in construction field. We are coming out with some of the mix design up to M50 MPa compressive strength of concrete. And by doing that, definitely your elevated metros, what you are seeing, the height of the piers, everything can be reduced because you can go optimize the beam depth. We'll see what can be done. That also we are taking up. Another one, instead of steel, we are going for steel fiber. Steel fiber, it is very good, and we have done some tests, and we already, the tunnel lining segments, we have already done some design. We have got approval. So people have to do some experiments. They should have that mindset of doing some experiments, what they want to do and how to come out. Another one, though the last one called as a geofreak, it's basically an instrumentation guy's work, but civil engineer, as a civil engineer, we want to know when you do the tunnel, how the ground movements. So we interacted with this guy, other discipline, and come out with a solution, and we have developed in-house a monitoring system which is implemented in Chennai Metro across all the packages. Because sitting at your home, you know whether what's happening to the TBM and what's happening to the ground movement, is there any abnormality, so immediately you can inform the designers to take rectification methods. So another one, this is also for the construction, we need to have some platforms, moving platforms. Yes, here hydraulics, mechanical, all these people are involved together, and we have come out of it. And you go durability, everybody talks about durability, sustainability, and how to arrive at. Nowadays, the client requirement, initially it was 100 years, now 120 years. And you can say, the Ayodhya temple was 1,000 years life. How to go about, what sort of material to be used? Is there a material which can last for 1,000 years? I don't know. But we have developed something where we can predict at least whatever composition we are using, how much durable it is, and what is the lifetime we can predict. Of course, 3D has become a norm now. I can say most of the buildings in coming years. But here also we have to come out with good material where we can go for higher floors. Now, ground plus one is the material, what they are doing. And I understand some places they have gone up to ground plus two or something. But when you want to do a high-rise building, then we have to come out with a material what it suits for this one. Similarly, we have done some marvelous project within very, very less time. Okay, there are some projects where China has completed much ahead of this schedule, but nevertheless, India also picking up. So don't worry that civil engineers will come out and beat one day. We will be the world leaders. Like one of the buildings for DRDO, we have completed in about 45 days, about 7-story building, and we have completed another 12-story residential building in about 96 days. Mostly it was precast and prefabricated. Now going forward, we talked in the morning, many of them touched on BIM and other things. We are just started. We are only crawling now. We have to fly. As I put, we are in level 2, some BIM and BIM simulation. And we have to go all the way because professor has told the digital twine, what they are used in mechanical has to be used in civil engineering field also. I think, yes, it is possible. And definitely Nemetschek will take the graduates to this level, so we can recruit directly from Anna University who can directly put, and we can start extracting work from them. And we also invested a lot of things on virtual reality, augmented reality, mixed reality, all these things. I'll show, it is easy for us, we talk about, these are the, you can say, a virtual reality or a mixed reality, whatever you call. Because there's an existing road, in that we want to construct some tunnels. So the client, the politician did not allow us, so we showed him how it can be. Anyway, he has to wear these goggles and other things, and we showed, without interfering the traffic in future, how it can be done, how it is going to show like. So this was easy for civil engineers, and they also should know how to use this technology. Of course, Nimechek will come with the advancement beyond this also. I hope they will come and they will teach the engineering students. Here, this is a real example of mixed reality. We had taken a photograph and superimposed how it is going to be in future. So this is in front of our office building where the metro is crossing. So we want to have a wider opening. So what sort of structure should be built? And we had to get approval from various authorities, why we wanted. So we did this one, we made a video also when somebody comes out of our office or enter into office, or how, when they're going, how it is going to look like. And we have made about 12 options. If we have to do in the olden times, it would have taken ages to prepare this one, sketches, 3D rendering, all this thing. Now it can be done. Within a week, we are able to come out with various options we can able to show, and the decision was able to taken quickly. So this, the technology is moving fast. We were talking about projects in years, we were talking in months, nowadays we'll talk in days to come. It is reality. And of course, drones we are talking, we are also trying to develop a drone which can carry up to 5 tons. With some technology partners, we'll do it. And robots, as I said, we are getting into a bigger role, and we will develop some of the robots which is suited for Indian construction. This is something which already has, you would have seen in internet, this iron pot, what you call, and it does placement of reinforcement, tying of reinforcement, everything by itself. And as you said, you create a model in the BIM and import it in this one, and automatically picks up this one. And a lot of autonomous vehicles are being developed for construction. Even a crane can be operated sitting in an office without entering into the cabin. So such facilities are coming. So people should be aware of it, what it is going to be happening. Another one, we are developing a steel. It's called a memory steel. It behaves as a steel. After heating, it contracts and behaves as a pre-stressing steel. So it's like a stent. The thought came from stent. If you pass a stent, it goes to a certain location, and because of the body temperature, it expands and stays like that. So this is a technology we saw, and we thought this should be developed. It's not going to happen overnight. We have a plan of next 3 years. We will be doing some trials with this steel which we'll develop. We are interacting with metallurgy faculties of various institutes, and it will be happening very short. So we have to keep our minds open. The concrete, steel, whether it will last longer or some other metal should come into the construction field. And this is my last slide. We were talking about trial runs of Hyperloop. The tubes were designed and fabricated by L&T and supplied. It's about 420 running meters, it is there. They did some competition last month, and this is going to be a reality. And if it is going to be a reality, they'll come with pod and other things. But how this tube going to be, what sort of metal to be used, what sort of sustainable material we should have for the vacuum creation. So this is going to be a challenge, this is going to be the future. And we know, like airports, how expanded. I think Hyperloop, especially in India, Hyperloop will be a success in coming future. Already, Railway Minister has invested 8 crores to IIT, another 8 crores recently has given to take it up one small pilot project, real pilot project. So the engineers or civil engineers have to come out with an option, what sort of span, what sort of material we can use, what sort of tube, whether it's steel or concrete, whatever is to be done. So coming to an end, as I shown you what we did, don't worry, civil engineers are doing wonderful jobs and they'll continue to do, and we'll excel in our profession. So we have to leverage on existing technology because we are doing construction for centuries, and we should learn what they did, how they did, and we have to improvise. And of course, digital, as we have seen today, one of the memorandum what they are signing on digital transformation, that is important. And BIM, and very happy what NC has spoken about AI, how it should be used, and automation. Integrated engineering approach, civil engineer cannot work by himself alone. It was days what civil engineer can do or were doing only construction part. Now it's not going to be. The world is changing. There are a lot of challenges what we are facing, so it has been integrated approach. That skill has to be started, that knowledge from college. And civil engineering is continuously changing, so skilling, continuously learning process has to be imbibed in the students who are coming out. Because the way when I graduated, we didn't have a computer at all. Our calculator was the luxury. And nowadays we do everything without a computer, without a laptop, you can't survive. So that is the way. So people have to, within 30, 40 years, what I am telling, now how it is going. The 40 years, last 40 years, growth was slow. And going forward, the growth will be much, much faster than what it was. So to do. And explore and create opportunities like Hyperloop, something else, somebody should come out and do this thing. Of course, we have to take care of nation, this environment, sustainable progress, sustainable future. That is a must, and that also be told to the students. To conclude, we make things that make India proud. I wanted, but I thought we should continue the legacy. You could have seen our monuments were built. You can see India, across India, you can see a lot of astonishing buildings were built by ancient kings and other people. So we were doing, so we'll continue to do. And I take this opportunity to thank Professor Jaya to invite me to deliver this keynote address. And in spite of other difficulties, I said, okay, since I've committed, I come here and to deliver. And I'm very happy to be here as alumni of this institute. I think this is the first presentation or second presentation, one presentation. Professor Shekhar asked me to come and deliver for endowment lecture for our great Professor Purushothaman. So this is my second lecture presentation. I'm very happy to be here. And as Nimishek said, we have to tie up with the industrial partners and what they need. And we are always there to come and tell what we need, how to go about. Thank you very much for this opportunity once again. Thank you.
Thank you, sir, for that enlightening session. Next, we delve into the role of NextGen solutions in civil engineering and architecture presented by the NextGen team. May I invite Mr. Nirmalya Chatterjee and Mr. Sivaram Balasubramanian from NextGen India to take the stage.
Mr. Nirmalya Chatterjee, an accomplished leader in the AEC sector, holds an MBA in sales and marketing along with a background in civil engineering. As the regional managing director of NextGen Group in India, he drives digital transformation through BIM solutions. With extensive experience at Tata Projects and Trimble, he has led strategic initiatives in business growth, digital product development, and operational excellence. Mr. Sivaram Balasubramanian, he is an architect with a master's in construction project management and a certified ArchiCAD BIM author and coordinator. With extensive expertise in BIM technology, he specializes in its integration into architectural design and project management. His contributions have been pivotal in optimizing workflows and improving project efficiency.
Welcome, sir.
Thank you. Actually, this presentation was supposed to be made by one of my colleagues who got some medical emergency. So I have to come on as a replacement of him. It's challenging because this presentation is purely technical. And I need to now brush up my 26, 27 years back civil engineering know-how to justify this presentation. So Let's me try to address what, as an MHA company, we going to do and what are our advantages for the industry. So we have into 3 to 4 pillars. One pillar, which is the planning and design, which is morely our solution goes into that. Then the build and constructions, operate and manage. The last one piece, which is more of a media entertainment, which is not the subject for today, but we have solutions which is also being used by the Bollywood industry and the Hollywood industry. So we are mixed into that phase. But let's focus back to my first slides in the morning where you talked about it, the entire workflow from architectural to engineering to construction, how this workflow we combine together and cover this. But before we go into that, it's maybe a little interesting for all the students who are sitting at the back sides, that they need to understand what they're going to do. We have heard about BIM, we heard about the word 3D, then in the 4D, somebody will talk about 5D. You know, D is an unlimited. You can keep on increasing the D factors within the BIM, but I believe that the more focus has to be on that, it's a digital construction. And when I say digital construction, that means before the construction happens, the same thing, the replica is available in a digitalized form. That's a very simple to understand. Let's not get confused of whether I'm using 3D, 4D, 5D, 6D. Let's not talk about the D, but let's focus on this as a digital construction. Okay, so that's the primary focus for the students to understand. And if we understand that, then I'm going to relate this with some of those phases. First phase is on the civil or the structural engineering part. So we have a solution called RISA. How many of you are into learning this structural analysis and design in the backside? Raise your hand. Okay, almost everyone. Okay, good. So when we do that, and as Senthil was talking about it, our India codes as IS 800, IS 456, we have those guidelines. But within that guidelines also, it also needs to be included the international things. That's what Senthil was referring to. And exactly that, from the NMHA RISA solutions, we are advising and we are projecting to this consultant, to this engineering consultant, that with using RISA, they are able to get the Indian design codes, but at the same time, the international codes is also linked and also available. So you will be able to compare while you are doing your analysis and design part of it and take a proper impromptu decision for any of your projects. So that's our RISA application, which is for structural analysis and design. And let me try again to go back to my engineering days. When we do a structural analysis and design, we generally consider the node-to-node connections. Okay, so it's a center line part of it where there's the bending moment diagrams or the combination of the forces that we consider, and then the load combination factors is combined together, and then we derive an analysis, and based on those analysis, then we derive into what is the actual design will happen based on which whether the structure is going to be stabilized or not. Now, this is what exactly the RISA applications will do, where it will create a kind of a node-to-node connections for your structural members, but at the same time, it will also going to give you an options to see the physical part of the member. So when I say physical, so when you have a beam, a beam is a one node to the another node, and it's a one line, and this is only required for an analysis perspective. But when it goes to the construction, it needs to have the thickness, visibility onto that. So what is the 3D looks like also needs to have a visualization impact. So this RISA is going to give you both the analytical model as well as the physical model. So you can switch in, switch off, and whenever it is required to make sure that you take a proper analytical decision on this. Okay, so let's now move to Alplan, and now I'm going to connect with what Senthil has shown in his presentations. This L&T is doing excellent job into all the bridge aspect, precast projects, and how such projects can be also possible in a more efficient, qualitative way, and also the time-consuming aspect can be covered. That is something we covered through an Alplan technology. So what Alplan as a technology overall it does, it takes care of the entire ecosystem. So companies like L&T, when they involve first with a tender stage. And from tender stage, this goes into detailed part of how the 3D models will look like. So it's a tentative model at that time. Then the comprehensive, complex 3D modeling that needs to be prepared. And then once that is done, the visual scripting is also required to make it the more complexity part to be covered. And after that, the detailed automatic complex reinforcement. This is very important because when this project, it needs to go to the construction purpose, the rebar details there, it also needs to be visual into the model itself. There are some companies in the old days, what they used to do is they create a 3D model, they make it analysis and design, but when it comes to the construction, they still follows an Excel formula or the manual way of rebar. But that sometimes creates a problem because if there is a changes happens in between, all the rebar details that's placed there, it needs to be regenerated again. But if you involve or if you learn that one 3D model where your structural part details are there, the physical models are there, and then the data integrated within that with all the rebar details inside of the model is possible, then you will be able to generate your automatic design drawings. And that's very important when it comes to the precast part of it. So this is the one application which will cover from the concept stage, tendering stage, to a detailed 3D model stage, to data integrations within that, and from there the drawings and the bill of materials or the BOQs will be generated. And this is also helpful for automatic fabrication process. If you remember what Senthil was talking about it, that when he does this precast things, he sends these details to those fabricator. How we can make sure that the fabricators is also talking in the same language or they don't waste much time when they get the data from a designers or from contractors. That is very important. And this is the applications Alplan which connects this fabricator with the engineers and with the contractor itself. The next one is the site planning. This is also very important. You have seen what Senthil is talking about it. The site planning, like, what is the stages of the construction it is going to happen. So if you can use the same platform, same technology to use also the site planning, that is also going to help the overall part. Now, once you done all these, then imagine that example, again, I'm taking the example of L&T. L&T has a multiple, locations, offices, and maybe Senthil's teams are sitting in Chennai, some are in Mumbai, and some are in other places. How they're going to work together, how they're going to see what is the Chennai team is doing is also getting visible to the Mumbai team, or maybe his clients, some consultants are appointed, is an overseas consultant. They wanted to see what L&T is doing, and they can collaborate into that. So you need a complete cloud-based application where these whole details are available and each project stakeholders are able to connect and collaborate with together. And with this, the whole workflow process, if you can see, starting from the tender stage to the now, the entire work together is possible when it comes to anything related to the concrete, whether it's a precast, or whether it's a bridge projects, whether it's a simple housing project, this Alplan can take care the entire workflow. And we will be providing this Alplan as a part of your curriculum and will be implemented in your Center of Excellence. So the next one that I would like to touch upon is the bridge part of it. When it comes to the complex modeling, so you have seen from L&T's presentation, there are many complex projects nowadays are getting executed in India. Now, when there is these kind of complex projects are going to be a part of your job in the coming days, how are you going to equip yourself? So you should have the know-how of those technology whereby a complex modeling is also possible and make it life more easy. Give you a very small, quick brief of how this automatic reinforcement part. So here in this video, you'll see that there is a wall panel. In the wall panel, 3D models is done, and after that, when you're going to consider the reinforcement details to be added. So in our plan, what we do is we create a command and then select this wall panel, and that based on the design data, it picks up and it is automatically placing the rebar details within the wall panel. This is the fastest way, and imagine that if you have to do it in 2D, how much time you could have taken to get this kind of a detailed rebar placed within the wall panel. So that's something which is very important, because today's days time is a money, and in the coming days when you are going to get a job, your client will be always pushing you to get the job done in a shorter time, and without using a better technology, you will not be able to complete that. The next one, I'd like to highlight upon about the column. So now you have seen the wall panel. Now imagine that you need to have a column. Now in that column cases, what has happened, and I'm respecting to all the professors here. I'm just recalling back my 26 years back, so my engineering know-how. So I don't know whether I'm overstepping to this, but any of those projects, the column sizes are varies, but at the same time, some of the columns will be the same. For example, a column series of C1 would be 20 in the ground floor, then will be the similar onto the second floor or something like that. Now, how do you make sure that when you are doing this reinforcement, you select this column series together, and instead of one by one, you can select this, which is the common, if it is a 450 by 400, and those columns are automatically selected and the reinforcement are placed there itself. The same way on the beam. So when you have done a wall, then the columns, and now it is a time for a beam. And the second one, which is the 2D to 3D. Now, why I'm emphasizing this 2D to 3D point here is sometimes, you will be familiar to start with the 2D drawing, because that's a fundamental thing. It is very much required. Now, imagine the situation that you are into a job and you are a little bit familiar with 2D, or you are joining a company where the majority workforce are in 2D right now, but they wanted to migrate to 3D. How it is possible that one technology can help you to work on 2D, and at the same time, whatever you are doing in 2D, it automatically gets reflected into the 3D model part of it. That's the beauty of a good technology. So you can see it here, there is a hole connected, and this hole is automatically being taken care in the 2D drawing, and the moment it is taken, the reflection of the same in the 3D models is also taken care of it. So it doesn't matter whether you are working on 2D platform or we are working on the 3D platform, your project is actually built up in 3D environment itself. Now, little bit onto the precast, because even though India is not that popular for the precast, at least in terms of the housing projects, but yes, the precast is the one which is going to be the demand in India for the infrastructure projects. So how we can make sure that you are also get equipped to deal with a precast technology, whether it is coming to precast design or automated soft drawing generated from the same. So Alplan is going to give that facility. Look at this one quick video from this road construction part of it. So what we have seen, those who are the civil engineering students, you will be probably also going to be involved in the road projects. But when it is a road, it's also been involved not only on the roads, because along with the roads, there are the utility part, whether it is the tunnels, part of it is also, you need to work on that. So yes, the road alignment, road design is an important, but at the same time, the connected facilities on the roads is also going to be the part of the job. So one solution should be able to help you to address to this. So next comes to the civil engineering. Within that civil part, as I talked about it, the complexity of the bridge. And again, I'm referring back to Senthil's presentation on different complex bridges. Now you can see that if you, as a professional, as a civil engineer or a structural engineer, involved on such projects, there could be different type of bridges that you need to work on. And then each bridges, have its own complexity. How you're going to define to that? Like Senthil was referring to the bridge which we are also shown in our video, because that's a very iconic bridge, that's a very complex, and this is a very challenging project. Now, when you have to face such kind of challenging projects, you need to have a better technology to deal with that. So this is when you do that, civil engineering involvement in the bridge part of it, you can see on the right-hand side, the complex rebar details involved there itself, it also need to be addressed. So whether it's a template-based design, whether it's a parametric modeling, automated report from there itself, or a rebar details, everything possible under the one umbrella, under the one platform. Again, when you do a design or you are involved, you need to you are working for a consultant, or you could be working for a contractor companies. In both the cases, what you need to deliver is the drawings, because at the site, the construction guys will be required a constructible drawings, and how you can deliver that. And that constructible drawings also need to be minor level details on that. So you will be able to get generated these constructible drawings from the 3D model from the same application. So this is very important when you are going to learning the construction part of it, because once your design is done is okay, but after the design, the same design then goes to the construction, how the communication is happening, whether there is any missing piece of the information from the designer and the contractor is there or not. That's something which is the Alplan Civil is going to take care of it. The next comes to SDS2, which is for the structural steel. Now, Senthil and other professors will probably agree with me that when it comes to any project, and present day, you cannot be completely dependent on this will be only concrete projects. Depending on what type of the projects, whether it's a visibility, whether it's a steel material as a steel is going to be much more stable, sustainable, that's the decision people are taking. Mostly to those industrial areas, when there is some industrial plants are created or a warehouse is created, there the structural steels are more used there itself. So you need to also equip yourself on whether it's dealing with the structural steel. But when you deal with the structural steel, there is one fundamental difference comes in from your design stage to a construction or a fabrication stage. And that stage is, when you design, I talked about it in the analytical part of it, you have a node-to-node connection. It's a center line of the members on the beams, and the columns is also the center line. But when it comes to the fabrication or an erection point, in that cases, your center line access needs to be from the center to the top of the beam, right, or the top of the flanges. That is required for an erectable point of view. Now, how are you going to convert that? That is called conversion from an analytical or a design model to a construction model. And this is what this SDS2 is going to help you to do that it is going to convert this analytical model to a structural steel detail fabrication model. The other aspect, when it is structural steels are there, you also need to consider the connection design. When there is a beam-to-beam connection or there is a column-to-beam connection, there are connection design. It can be two type of connection. It could be bolted connection or it could be a welded connection. The designer decides based on that what kind of connection, or the codal provisions is also giving a guideline that what kind of connection. But it is actually depends on the calculations of the load calculation on the particular members on this. Now SDS2 is having an intelligence inside that it is automatically do the codal calculation and do the connection design itself. So you do not need to spend more time on doing the connection design, and the software automatically does that. And any kind of, whether it's a bridge projects or a kind of a simple building projects or a warehouse projects, the structural steels are there. You will be able to use that SDS2 for this. So let's very quick summary of that, from connection design stages to a detailed fabrication intelligence stage, to marking stage, to provision of the drawing on that, and then you can even hyperlink this to your structural steel details there itself. Better quality of the drawings, because again, the same things, we do it in 3D model, but the same time it goes to the fabricator or in the or a contractor, they needs a drawing. How can you get a detailed fabrication drawing which is then easily usable? So SDS2 will provide that, and you will be getting those softwares in your center of excellence, so you'll be able to learn that. Next is again the BIM Plus, which is a cloud-based platform through which you will be able to collaborate like a different disciplines, civil engineer or structural engineer or a fabricator or a contractor wants to see what is your progress of the project. Through this cloud platform, it will be able to quickly review this. A quick connection design, kind of a video file, you can see that these are the members which is connected with each other, and the software is making the automatic calculations there itself. It depends on the type of projects. If it is doing an India project, it will apply the India design codes, and it will give you all the design calculation, back-end design calculation. So what has happened is, if any designer wants to change, like what Santil has said, that the codal provision is a guideline and it is not a Bible. So in that case, if you wanted to change something based on your project's requirement, you know what calculation the software is back-end is given. So you take that out, and then you can apply your own connection clauses or a design clauses, which will software then going to automatically implement. Then fabrication, intelligence. It's also need to have an intelligence for a fabrication file. And I was talking about the same, that if you can look at the beams and how it has been taken care on the erectable part of the beams with the connection itself. So it is taking care, it is calculating that where these flanges are, and then it is also seeing how the option is given in a parametric way, that where you will be able to change the thickness of the plates or the access system of the plates, or where you can put the hangers, and the beams can be hanging out and going in for the fabrication. Now, the same way is a connections heap and valley. Those, when you're going to actually go in depth into those design stages, maybe in the 4th year, some of your courses, you will be having those details, so you'll be able to relate it when you're going to learn these functionality of the SDS2. The other one, which is the staircase modeling, which is, we call it, or the industry call it as a secondary member. Because what has happened is, the designers is primarily responsible for designing the primary members. They sometimes not consider the secondary members at the beginning stage itself. But when at the time of the construction, all the secondary members has to be there. For example, the staircase is a secondary member. It needs to be modeled. The designer always considered that what will be the considerable load for the staircase part of it, but they do not sometimes model it there itself. But when it comes to the construction, it needs to be modeled so that this detailed fabrication drawings are generated from there, and it is going to the fabricator or the contractor. So you will be able to generate this kind of complex staircase model within SDS2 itself. I was talking about the same thing, the BIM Plus, which is a cloud-based platform. You will be able to connect different stakeholders together and you will be able to monitor and review it. The next comes is the Blue Beam. What is Blue Beam? Again, it comes to the drawing. So what has happened is, let's take examples of any of the bigger construction companies, whether it is Tata Projects or Sapurji, L&T, any of that. They have more than 5,000, 10,000 designers or those who are actually reviewing the drawings. Most of the times, of course, L&T is using Blue Beam, but the others, what they do is they see that the drawings are coming as a revision. Because when you will be employed in a company, you will be seeing that a project is designed once does not mean it is completed there itself. It is continuously gets revised. And when it is continuously get revised, your drawings is also need to be continuously revised. There's somebody will be there who is maybe department of CUIC, QC, or maybe who's actually the approval authority of those projects. They need to review the drawings. They need to manage, what is my revision 1, what was my revision 3, what are the changes happens. Now, if you end up to working on a PDF drawing or a AutoCAD based drawing and you manually manage those markups, it will be huge time consuming. So what Bluebeam does, it takes care of the entire workflow of the drawing management, whether you wanted to review, whether you wanted to manage the review management part of it, whether you wanted to put a cloud marking on your drawings review part of it, whether you wanted to collaborate with the other members, you wanted to at the tender stage, you wanted to get a volume calculations from there itself, or the most important part of is the auditing aspect of how you're going to have the control of entire drawing. You do not nowadays need to print all the drawings. You can have a digital version of your project. And that's the Bluebeam is going to do, where you can take your drawings, put it into the custody, and then manage all the revision controls there combined together. So this will be also again going to be part of your course curriculum, and we will be providing this software. Quickly running through some of the international projects, so you know that where all these technologies has been used and what kind of projects this has been used. So these are the projects from Germany, and this is building projects. It is used it's used for the Alplan and Bluebeam as a combined together. This is a structural steel projects. I was referring with an SDS2. Then there is a kind of a recreation center. It's a very complex geometry you can see, and the details of that is covered through Alplan, Solibri, Bluebeam. There is a combination of Nemetschek technology which address the entire need of it. Precast, there is a many number of global projects is done on precast on Alplan because of its unique functionality that Alplan is providing. Then this is another project of hospital projects. So, any type of projects, you don't know when you are going to be employed, what kind of projects will come onto your table. So you need to prepare for every type of projects. So this is a hospital projects. Then it comes to the breach projects. It is again used by the Alplan and the Bluebeam combined together. And that's exactly what Santil has been referring to. The kind of breach projects is already executed through Alplan technology. Then comes the civil infrastructure. This is a port projects, Solibri, SDS2, Bluebeam combined together. It's a steel plant, again is a structural steel, so it is used by SDS2, Alplan and Bluebeam. On the transportations, on the airport part of it, you can see that the railway station or the airport, these are all our example case studies that our software has been used. The next comes is the road projects, and road projects is very interesting because in the road projects, there is, as I talked about, a lot of utility part is also been covered. So this is a very complex road projects, and it is used through Alplan technology. Then the power sector, also we have a huge number of customers who are using our solution for the power sector. And last piece, which we talked about it and talked about it in the morning, that how we can differentiate ourselves from any other technology company, and that is the one unique part from our end that we address from end to end. Whether you from the concept stage to a detailed construction stage, our solutions help any company, whether it is an architectural company, engineering company, construction company, or a operate and maintenance kind of a company. They will be able to manage the entire life cycles through this system. And these are some of the customer base which are already using. This is just as one simple examples of the bigger customers that were already using our solution. How we can help, I'm not going in detail of this, but what we have, the Center of Excellence that we are going to open, and we are providing the solutions to you, not only on the softwares, what we are also going to provide you is the course curriculum. So we have detailed worked out the kind of course curriculum it is going to be, what is the number of hours, which category, what type, because it is going to be, it's not that we are just giving you a software and you said, okay, you now learn it by yourself. We need to make sure that this is being properly done so that the students are get properly trained and then they become more employable. So we have defined different categories of the curriculum, what software needs, how many hours of training, whether it's a basic level or it's an advanced level. So these documents and details will be shared with your professors so that when they will be running the training program, they will be able to do that. Another important aspect is about the assessment. We will be also involved with your professors to make sure that the students who are getting trained, they understand properly, because everybody will be having their own ability of how much they will be able to grab, how much they're able to understand on this. So it is very important that we also maintain the quality aspect of the students who are getting trained through this Center of Excellence. So we will be giving our guidelines and suggestions of how you can make sure the assessment part, once this has been completed, before you actually give a certification programs to them. So I talked about it in the morning. These are the initiatives that we have already taken, and this is our fourth one in Anna University. I'm really, really excited to make this happen very successful. Thank you very much, everybody.
Thank you, sir, for that informative session. I now invite Mr. Sivaram Balasubramaniam on the stage for his presentation.
Mr. Sivaram Balasubramanian is an architect with a master's in construction project management and a certified ArchiCAD BIM author and coordinator. With extensive expertise in BIM technology, he specializes in its integration into architectural design and project management. His contributions have been pivotal in optimizing workflows and improving project efficiency.
Good morning and a warm welcome to everyone. I was planning to say good morning, but it's good afternoon already. So no issues. So I am architect Shivaram, and I am happy and feeling grateful to be here today as a student from Chennai. And in the next slide, I'd like to talk about the evolution that we have gone so far in the architectural and engineering and construction industry. So what we've been doing is drafting plans through a pencil and a scale on a paper, and then we moved slowly with mouse and a keyboard on a screen. But what happened is we just stopped there. We didn't evolve later. We were evolving very slowly. So even with people today, they all know BIM is there, but they think BIM is just a trend and it is not a evolution. So what I'd like to say is BIM is here already, and it is too late that we are not adopting to BIM. And according to construction global waste, 30 to 45% is India's so it is better that we start adopting to BIM and switch our traditional workflows to the 3D workflow. And to talk about BIM in a simpler term, so BIM is just about a digital twin of a building. So it is not just a 2D representation or the 3D model. The 3D model should have all the information that is from the building. And the BIM model should also, the building model should also let us collaborate with all the users and stakeholders from the involvement in the building so that it can be tracked and collaborated efficiently. And also life cycle management, if we talk about life cycle management, the BIM model should be a source of information throughout the life cycle of the project. And I will be talking about Vectorworks, ArchiCAD and Solibri because I am from the design background. And so Vectorworks is a versatile software. It has a flexible modeling capability and it also caters a wide range of professionals. And Vectorworks is a combination of computer-aided design and building information modeling. So it is like a combination of both 2D drawings and complex 3D models. And Vectorworks Landmark is a product that is used by landscape architects. It is an extensive tool for modeling terrains, analyzing site conditions, and also for contour mapping, grading, and site analysis. It also has an entire extensive database of libraries on the plant species that landscape architects can use. When I talk about landscape, it's not just landscape, it also includes hardscapes and softscapes, like pathways, patios, and retaining walls. And Vectorworks Architect is a model that widely recognized by interior designers globally. And Vectorworks Architect is a tool that lets you create any type of presentations like the ones that we make in the conceptual stage, like a mood board or a material board, something like that. It also has a superior documentation tool and a list of attribute controls for quality drawing. And we can also create stunning renderings directly from the model. And here is a list of case studies that I want to show. And here we have the Changi Airport from Singapore, which is known for its landscape, and another airport from the Madrid Baharas is known for its interior parametric designs. And the next product or the solution which I want to talk about is ArchiCAD. So ArchiCAD is a comprehensive BIM authoring software which will help architects and engineers design, document, collaborate on building projects very efficiently. So the concept of ArchiCAD is that the 3D BIM model should serve as the central source of information. As the single model concept here, essentially ArchiCAD will allow you to create a single centralized 3D model, and this model is not just for a representation. It has the comprehensive database containing information about the building that includes creating the 2D documentation for 3D visualization, structural analysis, energy analysis, and interior design, and even schedules. So here is the concept of how ArchiCAD works as a BIM software. So as the data enriched 3D model is here, I cut the 3D model in a vertical and horizontal axis. So that gives me the viewpoints which we call as plans or sections. So once the viewpoint is created, I can create multiple views out of it. For example, I can create something as a ceiling plan or an electrical plan or a floor plan with just one view. So with those views, what I'll do is I'll just create my layout book and I'll put these views on my layout book. And layout book is nothing but our paper space which is defined as A4, A0 or A1. And then a bunch of layout book is thrown inside the publisher, which is the submittals that I need to prepare for. So thus, when I say the smart objects in ArchiCAD are not just representation, when you see this example of a wall here, it is not just the 2D lines that define a wall. It also it also defines what is the structure of the object, and it also contains information such as the pricing, manufacturing details, fire resistance details, and such. And the most favorite part of ArchiCAD is that the design philosophy of ArchiCAD is integrated directly into the workflow of a design, and the graphical interface is much user intuitive and interactive, and it is also quick to learn and fun to work with. There are many on-screen input aids like smart cursor, the magic wand, and guidelines, snap guides, and these are like a tools that will help us create our designs very efficiently. So to talk about productivity, we have an integrated library of 3,000 such smart objects which can be localized to our national standards and which is ready to be used inside our design. And we also have automated documentation, which I explained how the concept of ArchiCAD works. And we also have an automatic connection of elements, which is based on the intersection priority of building materials. For example, if I know that this slab is cutting through the wall, so I decide my material intersection priority of slab is greater than the brick wall. But similarly, you can see the plaster is not cutting the slab. So I define it in such a way that all the connections are automated and it is easy to get accurate 2D documentations. And to talk about collaboration, ArchiCAD is a true open BIM software where a BIM software should allow multiple users and multiple discipline parties to work together. So we have IFC, the Industry Foundation class is the open BIM format, which is nothing but how PDF is for 2D drawings, IFC is the format for 3D models in the BIM industry. And here is a list of softwares that ArchiCAD is collaborated. For example, we have softwares like Twinmotion, Lumion, Cinema 4D, and these softwares can be used for the visualization purpose. And for post-production, we can use Adobe Suite. And we also have the Rhino Grasshopper connection for parametric design. And we can, of course, obviously collaborate with other Nemetschek products like Solibri, Bluebeam, etc. So here is a slide which I was talking about, the ArchiCAD Rhino Grasshopper connection. So this connection bridges the gap between the free-form algorithmic design and the structured environment of BIM, which helps architects to create innovative but data-rich designs. And to talk about presentation, ArchiCAD comes with a built-in rendering engine Cinemaware, which is developed by Maxon, and which we can use to create photorealistic renderings inside ArchiCAD. And of course, we can also extract or export directly to Cinema 4D or Twinmotion or 3ds Max to make professional presentations and such. And AI Visualizer is a relatively new and evolving feature in ArchiCAD. It is a generative AI tool, and based on a concept model and the text prompt, the AI Visualizer can generate renderings or conceptual images which can be used as inspiration in the conceptual design stage. And for example, you can see here there is a conceptual model and a text prompt given as modern concrete residential. So based on the model, the AI generated image has been developed. So we can keep editing the prompt, like I need the same elevation with a wooden facade or a brick facade, and the AI tool automatically gives you such creations, and that can help when clients or the students can extensively use it for projects and competitions. And so BIM Cloud and BIMX are cloud tools which will enable internal teams collaborate together through teamwork. And we also have BIMX, which is a presentation tool that runs on every operating system like an Android or the web browser, and it will extensively bridge the gap between the internal stakeholders and the external stakeholders. For example, if you want to bring your project to your client, you can just take the BIMX app on your tablet, and this will have all the 3D model and your 2D documentation, which is not just a representation of your 3D, but each and every click will give you the details that is inbuilt within the 3D model. So the client can also export PDFs directly from the model, or he can measure and check and mark and communicate back to the design team with the BIMX model. And there are many comprehensive tools within ArchiCAD, but I'd like to highlight a few, such as the Rhino and Grasshopper connection, and real-time sun shadow study, and something like a distance guide which gives us on all 4 direction when we place an object inside our model. And we have design options and keynotes. So some of the case studies that include the Parliament building of the new Parliament building, and we also know the Pritzker Prize winner B.V. Doshi is a long-time ArchiCAD user. And so the next product that I'd like to talk about is Solibri. And Solibri is nothing but a strong tool for model checking and collaboration. So Solibri works with IFC format, so it doesn't care about which authoring tool the model is made. The Solibri just imports IFCs from various BIM softwares, and it can federate those models, and within the inbuilt and customizable rule templates, which we can customize and check our models on rule based. And the software is also the software can also integrate with multiple other softwares through the IFC format. And here are some of the feature highlights that I like to talk about. The model checking capability of Solibri and clash detection. So here we have the model checking capability. It doesn't just check the model, it checks for its geometry, clearance, and model revisions, fire safety, and more. And within the built roles, we can set inbuilt predefined rules for the roles, and we can check our model according to it. And even if the model is not classified properly, Solibri has inbuilt classification tools which will let us tag our building elements so that we can filter out and get extraction of information out of the model. And then about extracting models, here we have the information takeoffs options from the Solibri. It will let us extract all the information in our pre-built Excel templates. And communication and collaboration happens through BCF format. Solibri can talk directly to the authoring software. For example, if it is from ArchiCAD or Revit, it can directly talk when we exchange BCF files back to the software. We can also automate these design checks on a desired time period, and we can set the BCF to automatically transfer back to the authoring tool. So the Paris Olympic 2024 Athletic Village is an example for how all these softwares can come together and make a great example out of it. ArchiCAD, Vectorworks, Allplan, and Solibri, all of these softwares is used for this particular project. And next we have our curriculum, which not only just gives you the software, but also the learning material, courses, ebooks, and self-paced videos, and stage-wise certifications like the BIM author, coordinator, and management courses are added. And these certifications will be very valuable to one's profile. So to keep evolving is the only way to keep learning and skilling ourselves. I myself spend an hour or two every day and prepare for the BIM manager course. And So with that is all with my 30 minutes. So I'd like to end my presentation here. Thank you everyone for being a great audience. I hope it was an informative session. Thank you.
Thank you, sir, for that informative session. Now we will be having a short AV. So I request you all to direct your attention to the screen. Now we move on to our first panel discussion, an exciting conversation on innovation for a better tomorrow by leveraging technology, the role of civil engineers and architects. As our session moderator, we have Mr. Ranjit K, Managing Director, Hygia and Director, Atal Incubation Center, Anna University.
Mr. Ranjit Kovilinkal is a health tech entrepreneur, mindful leadership and resilience coach and director at Atal Incubation Center, Anna University. Holding a PGDM from IIM Ahmedabad, he brings over 16 years of experience in mentoring startups and fostering innovation. He is also a guest faculty in counseling and psychotherapy, an active member of CII's health and manufacturing panels, and an educator with the National Entrepreneurship Network.
Let's have a big round of applause. Next, we will be inviting the panel members one after the other. We cordially invite Mr. M.N. Arun, Founder and Managing Director of Casa Grande Constructions. Welcome, sir.
Mr. Arun M.N. is the founder and managing director of Casa Grande and its group of companies, bringing over 2 decades of expertise in the real estate sector. An MBA graduate from SCM HRD Pune with a BE in Electronics and Communication Engineering from Hindustan University. He has been instrumental in shaping Casa Grande into a leading real estate brand. His contributions to the industry have earned him numerous awards, including Luxury Project of the Year and Real Estate Developer of the Year. With a strong commitment to innovation, he continues to drive growth and excellence in real estate sector.
Next up, we welcome Professor Dr. K.P. Jaya, Head of Structural Engineering Division, CEG.
Dr. Jaya KP is a professor at Anna University, Chennai, with over 21 years of experience in structural engineering. She holds a PhD from IIT Madras and currently serves as the head of Civil Engineering Department, recognized with prestigious awards such as Best Women Structural Engineer and Outstanding Concrete Technologist. She is also an active consultant, contributing her expertise to the industry.
Moving on, we have Dr. Benny Kuriakos, Architectural Designer and Conservation Consultant.
Dr. Benny Kuriakose is a renowned architectural designer and conservation consultant with over 33 years of experience. He holds a PhD in housing IIT Madras and an MA in conservation studies from University of York. His contributions to sustainable architecture and heritage conservation have been widely recognized. He has been received multiple prestigious honors, including the Lifetime Achievement Award by Estate.
Finally, help us invite Dr. C. Valen, CEO of CBROS.
Dr. Valen C. is the CEO of CBROS Chennai, bringing extensive leadership experience in real estate and IT infrastructure operations. Previously, he served as city head at Capital Land and CEO of TRIL Infopark, where he played a key role in the successful development of Ramanujam IT City. With a background in civil engineering and multiple master's degree in management and environmental studies, he has been instrumental in major infrastructure projects, including Ascenda's IT Park and Mahindra World City.
Let's welcome them all with a big round of applause for the first panel discussion.
Thank you. Thank you to the organizers, the distinguished panel members, and the delegates. Before we start this session, a kind request if the members can move up to the front. I see a lot of empty spaces. You can occupy all the spaces in the front, please. This is the last session that we have before lunch. So let us show some spirit before we have a good lunch.
I request all the delegates to be seated at the front row.
So you can, there are a lot of seats. Don't check if it is reserved or not. You can sit wherever it is empty. Thank you. And if you still are trying to occupy the back benches, you can come to the front, please. Come to the front. Thank you. Yeah, so as you are settling in, first of all, I want to speak a few lines about this NEMICHEC MOU. So I'm also part of CII, and we are trying to do a lot of industry academia collaboration, because that is the way to go about. You have these industrial clusters, industrial parks, but unless you have industry academia collaborations or industry academia parks, only then innovation can actually move in a big way in India. So we are laggards when it comes to innovation. Even a country like China is miles ahead of us. So it is a wonderful initiative by NEMICHEC, specifically because they are not only providing the program in terms of what they will be teaching with respect to the software, but also they will be a part of your evaluation as well. So I hope if things like that can be taken up as a credit system within your curriculum, so that when you come out, you are immediately employable. So as you know, during the previous Vice Chancellor's term, there was an initiative wherein he made this 6-month internship as a credit. So you could take that as an option. Previously, what used to happen was there was only 1 or 2 month internships, and that was in no way useful either for the student or for the industry. But having a 6-month internship program is very beneficial, and I would encourage the university, since there are a lot of teaching faculty here, to bring in a lot of these industry collaborations, and also create some kind of credit courses through these industry collaborations, so that the employability of the students can increase. Because if you look at it in terms of the core educational disciplines, which is civil, mechanical, electrical, I understand only 30 to 40% get placed. If such initiatives are brought in, it will bring about more placements, and this in turn will make sure that more and more students come into these disciplines, these core disciplines. Because if you look at civil engineering from a perspective of Maslow's hierarchy, So we represent the first part of the pyramid, which is your physiological needs. So you have food, you have water, and then you have shelter. So whether it is residential buildings, commercial buildings, even things like ships, aircrafts, and everything else wherein you need civil engineers and designers, we are providing that base. And if that base has a lot of innovation that goes within it, then you can know that you can also achieve the other parts of the pyramid, the higher parts of the pyramid as you move along. So this is my humble request to the university to bring in more of this industry collaboration and then create credit courses out of it so that it is useful for the students. So with this, we will start the panel discussion. So we have a unique range of panelists out with us, each experienced in their own fields and each a stalwart in their own fields. The topic is innovating for a better tomorrow by leveraging technology, the role of civil engineers and architects. Now, if you look at the role of innovation, it is generally assumed that it is all technology, right? So you saw a lot of technology which was presented in the morning, and most of it I think went over my head. There was also a presenter from L&T, Senthil, who was asked a question as to what will happen if this fails, and because he was referring to Dr. Shekhar most often, we were having a small discussion saying that, okay, if it fails, then you ask Dr. Shekhar, because he is the one who taught me. So, but his answer was different. So there was a lot of technology that was spoken about in terms of innovation. But innovation is not only technology. Technology is only a small portion of it. Okay, there is a lot of things which goes around. What is the process? What is the products that you are using? Okay, what is the kind of people that will bring about this innovation? And that is what the esteemed panel here is going to discuss and debate about. So we have a few questions to the panelists, and I would be asking them in no particular order in terms of what are their views. So only request to the panelists is that when you speak, kindly restrict it to 5 minutes, give a few examples, and also look at it from a perspective of sustainability, resilience, inclusivity, and efficiency. So if you can bring in all these elements, whatever you speak about will not only be useful for the current generation, but also will be useful for the future generation, and there are a lot of students here who represent the future generation. So with this, let me ask the first question to the panel, and the first question, since I would like it to be on infrastructure and sustainable infrastructure, my question is to you, Velan. So how do you look at building a smart city from a perspective of mobility, resilience, sustainability, and efficiency? Can you also give a small example? And the most complex task is to do all this in 5 minutes.
Yeah, very good afternoon, everybody. See, when it is called smart cities, what exactly it means, we all know. It is a kind of a satellite city or a place where we will have a place to work, that means industries or institutions, a place to live, that's about residential, the place to entertain yourself like retail malls and all. And the reason why the smart cities were conceived in the early stages was that because of the higher level of urbanization, the population within the city, which impacts this existing infrastructure. When you talk about infrastructure, like you can call it as roads, you can call it as water, you can call it as drains, all those things were getting impacted because of the urbanization. So these kind of smart cities where you have a place to work, place to live, place to entertain yourself, all those things came up as a combination of smart city, in the term of smart city. When it is a smart city, the name itself carries a kind of smartness, right? Smart refers to use of a lot of technologies. And one among them is that AI based, you can call it as smart mobility, you can use EV, you can call it as smart water meters, smart waste management system. All those things have been conceived as part of smart city design. But one important thing I want to talk about is actually when you are talking about technology, it need not have to be limited to AI, it need not have to be limited to BIM. When you, as a civil engineers, we come across 3 stages of any kind of development. One is design phase, second is execution phase, and third is operational phase. In all the 3 phases, today the technology is very helpful and handy. For example, in the early sessions, we were listening to the design phase and even execution phase, how the design drawings are provided and all. One of the important things I want to touch it upon here is that when you are designing, I'm also partly looking at sustainability as a core focus. I'm just touching it upon because I'm also from Indian Green Building Council, representing the board. My friends, there are 3 kinds of design phase. We know that concept design, schematic design, detailed design engineering, and then finally good for construction kind of thing. When you adopt any kind of initial phase of design, look at sustainability as a core focus, because today nothing comes, no design is happening or no construction is happening without sustainability in focus. So for all the students, when you are looking at actually design phase, look at it 3 areas of focus. 1, green buildings or sustainable buildings. What exactly it means? It uses less energy, less water, and generates less waste, but at the same time provides the comfortable or living indoor air quality. The second one is going for net zero. Net zero, what exactly it is? It can be energy related, it can be water related, or it can be waste related. That is the second step. And third is carbon neutral, which is slightly, that is why we are keeping long term of 2070 or 2050, because it is not only in your hands. You have to depend on various other elements, cement, steel, and all those things, also to be sustainable. So in summary, just quickly putting it to you, when you design a sustainable building. When you execute, execute it in such a way that the environment is not impacted badly. And third, operational phase. This is where that AI is more useful. People are have presented in the past how AI helped them in design, BIM helped them in design. Now I'm telling you how it is going to be operationally helpful. One of the cities, we all know Pune. Pune is one city where this AI is used for traffic control completely. And resilience is one more term you have used. What exactly resilience means? It is to prepare yourself, how you can able to manage the uncertainties if at all it happens. That can be flood related, that can be any kind of emergency, a tremor, or any kind of riots, or any kind of thing, how you are prepared using this kind of technologies. One small example, Pune, why I touched the city. I wanted to give the example of Bangalore, but still it has to catch up. But Pune is the city where AI is used for traffic control systems. When there is a traffic in that area, the traffic control systems operate automatically based on the traffic movement in that particular road to modulate that particular traffic in that particular road. Likewise, if you look at water system, in Chennai, we are all supposed to be proud of. In Chennai, all the reservoirs are all connected with our AI and water effective or smart water metering system, which is based on AI. Likewise, every rural place, now Tamil Nadu government is taking up sewage treatment plants and water recycling. All those things are happening through AI based. AI based how? What's the demand? What is the availability? How it can be managed appropriately, the supply happens or the treatment happens. So for all the students, I'm putting it with a small example. We have 1 more minute, I think. 3 projects I'm going to quote for your reference. One is in the Chennai itself, Ramanujan IT City was built completely with this sustainability in focus. Even if you look at the railway station opposite, Thiruvanmiyur station, we have built that footover bridge, connecting that upper deck to this other side of that IT park. So people can commute just like that from the station to office, walk to work concept. That is one way you can reduce the traffic problem, or that effective way of managing the transportation. Number two, you talk about Ascendus. I was part of Ascendus development as a CEO. If you talk about radial road project, recently we completed that. The first project in the country which was certified for net zero of all the three categories, net zero energy, net zero water, net zero waste. What I mean is, it's not to pat on my own. You should know that in your own city, these things are happening. If it means, what it means to you, it means any kind of challenges which can be managed using technology and sustainable way. That's what I'm putting it. And one more important thing, what I have listened to the earlier session, digital twin and BIM way of designing. Again, I'm telling you, digital twin is a wonderful tool for all the students and the faculty members. I'm putting it asset twin as well as operation twin. These are the two twins, we call it as technology-wise. You don't have to have that drawings at all stored. It's all digital. Every aspect of design is happening in 3D and it is stored digitally. No need for searching for the details after 15 years also. So that kind of tools are also available, which was used again the Radial Road IT Park at Capital and recently which I have done for the first time in India. So what I mean is, it's all passion. It's all with coming with your interest, passion, and also commitment for that use of technology and advancements. These are few things I thought I will put it to you and that over to the other speakers, and then I will take up some questions over a period of time. Thank you.
Thank you, Velan. You see, one thing which Velan again spoke about is what is industry looking at it, again from the perspective of being resilient, sustainable and inclusive. And these are some of the technologies which you need to understand before you graduate. So I was just talking to Professor Shanmuga Sundaram, and he was talking about having student volunteers who will act as ambassadors, and they in turn will call the companies for placements. So before this, what used to happen was the university used to call the companies for coming for placement. Now the student volunteers come and do that, then what happens? Naturally there's more accountability, right? And you also can question the your own colleague who is the student volunteer as to why they are only bringing so less companies, or why they are not bringing X or Y company, why NEMICHEC has not come, why some other company has not come, and so on and so forth. So similarly, when you come and listen to these conferences, the big takeaway that you need to tell your teaching faculty is to, is for them also to understand as to how useful these technologies are going to play a part when you go out from campus. So it is also your responsibility to put it to your teaching faculty in terms of bringing these kind of technologies into the campus. Okay, so it works both ways. Don't just leave it to the faculty. The students also should take ownership. So these are some of the methods by which when you go out of campus, you can be easily employable. Now I will come to my next panel member. So all of us have heard about Casa Grande. Arun, as a developer, three perspectives of innovation coming in terms of the products that you use, the process, as well as the people. So what are the opportunities, the benefits, as well as the challenges as a developer when you look at innovation?
Thanks so much. Thanks everybody here. Is it okay? Yeah. So I want to take one step back just to reflect on what is it that we are talking here on a broader spectrum. Construction, as everybody knows, or if you wouldn't know, is the second biggest employer in the country. Construction, the whole infrastructure industry employs 12% of the population, which is quite huge for a country which is maybe 144 crore people, more or less 1/6 or 1/7 of the population of the world. And just only after agriculture, which everybody understands is the largest employer of the country. Now we are talking about a very sensitive subject here, as much the problem is, there's a tricky space. One is that we want to be employing a large part of the population. Construction Because that's the only way to keep a lot more people employed and create a relevant ecosystem which has a sizable middle income or a lower middle income population which can sustain by itself. The flip side is obviously we are talking about the excitement of the newer technologies and practices which we would want to bring in. The biggest bane and the difficulty of this industry is it's extremely labor intensive. It's extremely laborious industry we work in. But the good part is obviously it employs a lot more of the talent pool of the country. What do we do here? When we go for a cutting edge technology, be it in any form whatsoever in terms of newer construction practices, AI implementations, BAMs or IoTs or whatever technology is going to be implemented, the problem is it's somewhere going to start retarding the labor. But the truth remains that the most difficult part of our industry is a huge amounts of labor which we have to mobilize, train and deliver competent qualities. Because India is now seen across the world as one of the most important economies. It's the third, fourth largest in terms of economy. And if that's going to be infrastructure in the next 10 to 12 years is the key. As much as we want to keep comparing ourselves to China, if you have to look at the way China, the infrastructure is there, they are like 10 times of what possibly we have already done. That's the gap we are now talking about. So to bring this in and to bring this, the only way we have is to ensure technology adoption across every part of the space, be it in terms of process, be it in terms of people and whatsoever. Now that we are, as industries brought torchbearers, we have, as a company, we have our inroads into residential. We do one of the largest in residential. We do close to about I would say 2,500 crores worth of concrete pouring. That's a value we do every year and it's only going up. So we are into office spaces, we are into residential spaces, we are into industrial warehousing parks. We are realizing that unless we move to the newer technology, it would not sustain us. But the flip side is actually if we don't balance it with the social angle of the employment which currently the civil industry is generating, we might be in a fix. So this is the constant predicament which even the government, I feel, somewhere has. The fact that as much as we want to be very progressive, this is always far more received well in countries where there is a lesser labor supply. In our country, first of all, there is a labor supply. But the problem is the skill set development of the broad labor which is being engaged. So in this, the government's predicament is also that they really, as much as we have represented in many forums, many of the construction practices and newer technologies are quite expensive and it's made to be expensive that way in India. I believe is also because of the balance or the trickiness of whether they want to tilt towards more technology, which means we don't need labor. Currently, we have a 14,000 people, 16,000 labor currently working on a site today, today. If you were to bring in the newer tubular structures or a precast structures, etc., it could drop down to as low as about 60 to 70% of the number. Then what happens? So this is what is a space we are in. But yes, of course, as developers, we have been very progressive in terms of adopting newer technologies. We have moved to the newer software tools. We have moved to the newer practices. In fact, all our structures today, though, let's say, my one structure, which is an expensive affair today, but we realize the quality is far, far better. We can depend less on people per se because primarily the whole structure is out with that. So even if it doesn't involve enough repetitions, which normally it takes at which the cost becomes optimal, we've gone for it. Because we are finding it difficult to do without that. And we are now putting up our own precast plant per se. So these are the things which is bound to come by. So as a builder, from a builder's perspective, we are very, very clear that the space when the infra is going to boom in India, for next 12 years it's going to boom, but we have to tackle this with only technology advancement. But we are in a spot where we have to balance it out in India as a slow progress because a disruptive movement of technology could suddenly shake the socio-economic structure. So that's a very different angle I might want everybody to be cognizant of, because government is actually quite, I think, with this 12% population is employed, then what do you do with them suddenly? So this is my view on that, yeah.
Yeah, thanks, Arun. So that's a very important point as to how do you balance the labor and the tech component when it comes to innovating yourselves. Where do you find the right balance? So I was just putting this example also to the group when we had a small chat just before this discussion, that even in a company like Tesla, Elon Musk feels that his factory is much more mechanized than what he wants, meaning to say that he thinks that now he could have employed a little bit more labor than the kind of mechanization that is there in the plant. So that is always a delicate proposition, and as Arun said, if you look at a country like India, wherein today, to be frank enough, labor is cheap, right, when you compare it with technology. So you need to create that right balance and then take it up. So thanks, Arun, for the feedback. We'll next move on to an architect's role in terms of how he is looking at innovation. See, architecture and innovation have greatly evolved because from architects, as you know, are innovators, right? So, however, from a perspective of how they view and use technology has become completely different. Today, as we said, innovation is not only about using digital tools or the software and hardware that come with it. Even you can use eco-friendly material. Okay, that is innovation. And architects are pioneers in developing all these kind of products and solutions. So, Arun, from your, Benny, from your perspective, what is your experience in terms of innovation when you look at it like this from a use of eco-friendly products and solutions, and how are you looking at innovation from an architectural angle?
Okay. One is I have a throat problem, sorry about it. Innovation is time consuming. You have to invest time in it, and it takes time to come over it. Here in India, the problem is slightly different. For example, sustainability, green buildings, global warming, climate change. I think as a whole, the profession, which includes me, is not taking it very seriously. When I got into this issue in the perhaps the 90s, I thought that I will never have to face this problem. I thought only my grandchildren are going to face this problem. But in 2000, I realized my children are going to face this problem. But now, I'm facing that problem. And if we live for another 15 years, I will see worse consequences of this climate change and global warming, which is going to happen. So I don't know, some of the youngsters who are sitting in this room, the situation is very bad. Chennai had floods, which is very common. Bangalore had floods even in the summer. Vijayawada had 1 year's rain in 24 hours, very close to that. The cars were floating. This is the same situation. Spain, few months ago, the cars were floating in the street because of the floods. And all of our politicians and scientists have come out with a new word, cloudburst, which was never there before. So this is a reality. The problem is there. The problem is around the corner. And looking at a person who have been involved in similar kind of issues, we are talking about technology. Technology has not found a solution. Technology is not going to find a solution to this problem of global warming and climate change. Unless we take a very drastic step on this. 40% of the global warming or the greenhouse emissions is due to buildings. 40%. Of which 8% is the role of concrete. It's a major contributor to global warming and climate change. If we take it on a country basis, next to China and US, concrete is responsible for global warming. I'm not saying that we should avoid concrete and go back to the old days. I know it is impossible to do. In many of the conferences like this, I tell jokingly, I mean it's true, by 2050, government will bring a ban on new buildings. It will not be a surprise because it will become a question of life and death. It will be similar to the lockdown where government will say you should not step out of the house or you should put a ban on new buildings. When we look at sustainability and global warming, why are we not looking at recycling the building as a whole? Because it has already made its impact on the environment. The greenest building, if you repair an old building and reuse it, it will be much more greener than the platinum, triple platinum rated building. Why are we not looking at such a question? I had a researcher coming from a university in Europe. He wanted to know, for example, Kevin, who is sitting in front, he came to interview me in the morning. He is working in Germany with eco-friendly villages and is looking at climate. His organization is trying to fight climate crisis. See, one thing which is very clear is that the solution to the climate change and global warming will be bio-based. There is no doubt about it. Which means it will be timber, it will be plants, it will be, could be bamboo or any of those things. In India, I was just listening to a WhatsApp video yesterday. 10 years ago, only 10% of the country was digital. Now 48% of the country is digital. We have made progress, yes. But at the same time, we have to see the number of houses without toilets will be 60%. We have to see the contradiction in this. If you look at when I passed out, there were 20 million families without a house, with so much development, so much new construction, so many engineers and architects. Now the statistics is 60 to 65 million people do not have houses. Now how is these houses going to be constructed? It will not be even earth. A lot of people said earth will be the solution. Mud will be the solution. I will say, where is the mud going to come from? Forget about where is the cement going to come from, where is the steel going to come from, where are the other materials going to come from. Building industry requires so many materials. Looking at this thing in a holistic way, it is not easy to find a solution to these problems. I'll give you another example which you might think. An average Indian produces 1/10 of the global warming and climate change. Greenhouse emissions. An American, I don't remember the exact statistics, an American citizen on average produces 16 metric tons, but an average Indian will be producing 1.6 or 1.8. An average Ethiopian produces 0.1, the African countries. And some of the countries like Qatar, Saudi Arabia is producing 35 to 40 metric tons per capita. Looking at this, if an average Indian produces the same amount of greenhouse gas emissions like an average American, the world will come to an end. Already Delhi is unlivable. Two of my friends have called in the last 1 year. They're settling back to Kerala because they say Delhi is unlivable. And one of the diplomats from the Dutch embassy told me, they get a letter when they're coming, don't take the children to India. Means don't take the children to Delhi because Delhi is so polluted. You have to understand, even before Corona, they used to be distributed en masse. Alternate odd numbers of cars on one day, even numbers of cars on the other day. Where is this leading to? We have to understand the reality. If we think about the future generations, we have to completely rethink the process on how we build, how we do buildings. Of course, technology will come to this aid. I just want to talk about one building which was inaugurated 2 years ago in Austria, Vienna, Austria. It is a 24-story timber building where 76% of the material is made with timber. Now, in the next 2 years, one more new building, which is 26 stories, is going to come up where bulk of the materials is made with timber. Personally, 10 years ago, I've seen in London city multi-storied buildings which is not built with, where bulk of the material is not steel or concrete, bulk of the material is timber. I mean, last year in Europe, I saw a 80-foot span structure built with timber. They call it cross-laminated. Why are we not able to look at these kind of materials? Because timber is the most sustainable building material which you can have. Because if you use more on timber in buildings, the carbon is not emitted, carbon is stored in the material. The moment you allow timber to decay, use it as a firewood, carbon dioxide is emitted. That is the carbon cycle you learn in schools. But timber is very sustainable. Anyway, most of the trees has to be cut at some point. Coconut trees has to be cut after 60, rubber trees 30 years. After that you have to be, so looking at these points, we have to see at alternate building materials. We have to look at new possibilities. We have to, I'm not saying we should be influenced by the best, but we should look at more possibility. I've done a building in Kalakshetra with a timber roof structure, one of the auditorium. Both the auditoriums were done by me, one is completely done. I approached the structural engineers. The structural engineers, Chennai mostly was not able to design a timber structure. It is the span is 60 feet. They were not willing. Finally, I had to approach Jaya. Jaya, you remember, 10 years ago, Jaya designed a timber structure, a combination of steel and timber. Now we had to change our thinking process. We had to change our curriculum. Unless we do it, the future is a little bit bleak. Sorry to say this. I'm optimistic about it. If we don't correct ourselves, the nature will correct us. And that is what you see. So you see in Wayanad, or that is what you see in the floods. Nature will correct ourselves. Thank you.
Thanks, Benny. That was very insightful. So even though you created fund stands for fear, uncertainty, and nagging doubt. You know, the points are well taken, and that is what the need of the hour is. So as Benny rightly put it, we need to use products that are eco-friendly from a sustainability perspective, because that is what the need of the hour is. It was nice of you to give this statement to the audience. I think everybody woke up before lunch hearing to Benny. Now, let us move to the last speaker, Professor Jaya. So, since Jaya is in academia, I thought let her ask me this question as to how you can look at bridging academia and industry together. Because as we discussed the NEMICHEC collaboration, how can we have more of these NEMICHEC collaborations? And it is not only about having these collaborations, it is also about executing and operationalizing it. You know, so I said, as we discussed, create some credit courses or make sure that you measure the impact and the outcomes, and then you build such programs that can be best practices, wherein you can not only roll this out to other disciplines, but also you can take it across the community, state, and country. So if you could throw some views, Professor Jaya, on this, how we can actually not structure industry-academia collaborations, but how do we restructure industry-academia collaborations for the benefit of both industry and academia, because all the people who are here, who are speaking today, whether it is Arun, Velan, or Benny, they would like to see students who are more employable coming out of campuses.
I'll not take much time because I know that everyone is feeling hungry. And the thing is, like, just now we heard that from Dr. Benny that there will not be any building after around by 2050. So my worry is like, then why our children has to study further on the structural design part? Almost all engineers who are sitting here is structural engineers and construction engineers. And now then we have to look on to what environmentalists as well as the water resource people has to work on that. So I think there will be a cycle. There will be up and downs. Once multiple structures are coming up, it may go down, then later part it will come up. So that's there. There will be a cycle always. And as an academician, I could say that I could just refer around by 2024 analysis, by the year 2024, by the analysis says that around 51.25% of the graduates graduating from the engineering colleges are employable. The question is a very big question, skill development, employability and all those things. But my wonder and my worry is that we have to do some modification in the curriculum that the children has to be employable. And latest revision of our curriculum, we have done that. And it has to be a dynamic curriculum. We have to engage industry people also in the development of the curriculum. What is the need of the society? According to that, we have to change the curriculum system and whatever be the syllabus and all those things we have done in the last revision 2023 revision, we have done that. And the bridging between the industry and the academy, our students are very proactive. We have various societies and student activities there in the campus, and it is called the Society of Civil Engineers and all those things. It is not only within the campus, across the Tamil Nadu, each and every college we have our student, they used to conduct lot of technical sessions, seminars, and bringing in expert to discuss the matter with the students. This also, it's happening across every semester, every, what I can say, academic year. And there is a calculation is that by around 2035, the year 2035, around 92 million skilled graduates will be coming out of all the colleges. At present, it is only 48.7. Now we have to look into the factor that where we will employ and how we will employ. Whether they are employable in the, whether they comes out as a skilled one. There, that part we have to look into that. And with respect to the new technology, and I think Arun was commenting on the precast technology, and Valen sir also was talking about the sustainability structures. And of course, we are training our children in the precast technology. We are running the course, and they will be well versed with that particular. I am talking about only one case study, like precast technology, they will be well versed, as well as the Maivan technology, they will be well versed. We are teaching them formwork, and all those things they will be working on the cutting edge problems. With respect to the climate change, we have a center called Center for Climate Change and Disaster Management. We have a very good studio on that. Data collection is that. The government of Tamil Nadu is very keen on developing that climate change center. We are sure that we can. And we are always in touch with the industry people. They will come forward and they will support our students. And especially with respect to this present, today's MOU signing, this has started last year. They were discussing about how we can improve the skill of the students, especially without AI, BIM, and machine learning. Now the civil engineering is also not at all possible. So we have worked on that. And the next thing is like all the research activities has to be done in collaboration with the industry. Whatever is the need of the industry, we have to find out. Accordingly, we have to develop the research topics. For example, today morning, Dr. Sendilnathan was commenting about memory steel. It is a very good topic to work on to come out with a solution on the memory steel. And there is a very good area is on ultra high performance concrete. Most of our children can work on that. Like that, each and every need of the industry can be enumerated, that can be worked out, and we need to get funding for the children to work on that and come out with a solution. We can have a proper interaction between the industry and what I can say, academia. And Hyperloop, morning somebody was commenting on that. That has been developed in IIT satellite campus in collaboration with L&D. Like that, there are a lot of things are happening in and around. We cannot say that the children are not skilled. How much we can improve their skill, that only we have to think about. Thank you. With a small note I'm holding here, one final address is that our children are so smart, and how we can, what I can say, equip them with the support, what extent we can give.
Yeah.
Thank you.
Thank you, Professor. I hope this gets really implemented and it is just not talk, because what we have seen is specifically when it comes to industry-academia collaborations, it is the teaching staff who sometimes are not wanting to bring in these technologies because they feel that they have also to learn in the process, and sometimes that also acts as a kind of breaking point wherein things do not move forward. So if the faculty also is more open and dynamic, which I'm sure professors like Dr. Jaya are, and the teaching faculty at Anna University, I think this can really be taken forward, because it is not about bringing this MOU. Okay, fine, this MOU has happened, so what? So after 3 to 4 years, unless you can measure the impact and the outcome, and then create best practices out of it as to how you can increase collaborations like this, only then it will be felt on the ground, right? Otherwise, there's no use of, we have been having collaboration is not at all new. It has been there for decades. But where is the outcome? Why are still, today we do not have a trained manpower. India, as we are discussing, we have a very large workforce. So these are some of the critical questions that faculty also need to answer. They also need to do a lot of brainstorming and then, come out with critical points which they can also put forth to the industry and then take this forward. Okay, so yeah, if you have a quick point.
See, I just have only one thing which to answer to you, the faculty members to be part of kind of thing. So recently we were discussing with Professor Jaya, Madam, most of the faculty members in this structural department, if I'm not wrong, have come forward to get qualified themselves first. Accredited faculty program for that green building certification, which I was also facilitating to some extent part of, but all of them came forward before they go and preach to the students.
And one more thing I want to add on that. We have Professor of Practices in our department. Professor Velan is one of that. And honorary professor is also there after so many years of retirement. Professor Shekhar is still continuing as a faculty. So all these are enriching matter for the Department of Civil Engineering.
That's a great thing. Only one more thing for the students and faculty members. NBC, National Building Code, Chapter 11, since I was talking about sustainability, Chapter 11 is exclusively developed for sustainability. And that can be reviewed and referred for your academic part of it also. Thank you.
Thank you for those points. One last quick question before we round up. Just 1 minute from the panelists. So how can we make civil engineering a glamorous profession? 1 minute for each of the speakers.
I run a large construction company, but actually I'm an electronics engineer. And that was sheer herd mindset. People, when I was studying, I mean, we are talking about way back, 93 to 97 onwards, actually civil engineering was not seen as, glamorous whatsoever. It never used to have a proper fill-in. I wanted to be a civil engineer or at least be a mechanical engineer, but both didn't happen because people said you'll find a better job with electronics. The beauty is it is totally changed. It's totally changed. This industry is there to stay for next 10 years to be the largest, biggest employment contributor with very, very glamorous career paths for everybody. We are seeing that today we used to engage a lot of people at a particular cost, and that's already gone up by 2.5 times, and I'm very happy with that. Because this is the industry which is building the country, building, the whole country in all sense. So, with the newer practices, obviously your profile and career growth will be even better. But even otherwise, slowly, even the new age sectors like knowledge and AI, etc. I mean, knowledge sectors like IT or ITES or whatever, etc. is all staying put at a particular levels because even that's become more a labor kind of an industry. Actually, civil engineering will be more glamorous going forward. If it was today, I would have chosen to be studying civil than electronics, which I did.
Yeah, my point is like this. See, Chennai city, if you talk about it, we used to see the highest building, probably Arun built it at many places. But when you talk about the 40-story buildings today in Chennai, it is very common in other cities. You can just count it in single fingertips, finger points, 4 or 5. I'm telling you, my friends, Chennai is coming up with 38, 40, 45 kind of storied buildings. In the recent past, many projects have started. It's going to be, which is first of its kind for this city. So everyone, even for example, my one and all we are talking about it, used to be there many times, but it is also now come up as a common practice when you go for such kind of developments. Students can focus on that kind of high-rise structures. And one more thing I want to tell the civil engineering students, don't limit it to only civil engineering. When you want to become a kind of professional as a project manager, you need to know about other discipline also, like basics of mechanical, electrical, and air conditioning, etc. If you are adding that a little bit onto your learning, it will help you in a big way. That's how we have been, because I'm a hardcore civil engineer, structural engineer per se, but I became a kind of sustainability. Sustainability not only limiting you with the civil, that is why I'm saying this. You have to have some other areas of focus also. The last one I want to tell is that today, since Benny was talking about a timber kind of thing, Indian Green Building Council has 6,400 green products already available, developed and certified, which means those are all sustainable materials. Reach out to those in the website igbc.in, where you can able to get to know those things also, and you can innovate many products. That is how one can. So just look at it. How do you develop yourself for the innovation practices and use of sustainable materials and the technologies for high-rise buildings?
Thank you.
Jay said that, civil engineers could be jobless in the future. And Arun says this is one of the growing industries. I agree with Arun mostly on that. 1/3 of the construction industry's money is being spent on repairs and maintenance. So if you spend 100 rupees in the building construction, 35 rupees is spent on repairs and maintenance. So when we have built, 2% might be the number of buildings which are coming up in every year, we have to maintain all these buildings. And for that, civil engineers are required to do these things. But forget about it. New materials or the way the building materials are used, there is going to be substantial change for which we need the technology and this. So repairs and maintenance is going to be when I took my master's from a UK university, there were 2 buildings in the library on concrete repairs. Now my library will have 20 books on concrete repairs. All these buildings have to be repaired and maintained. My professor in the first year, I took civil engineering. That is why architectural designer, everything came. But I never worked as a civil engineer. First day of my college in 1979, he said, you are going to design buildings which are going to last 750 years. In 1979, the thought process was that concrete buildings will last for 750 years. I was in Monday on a class, teachers training program, faculty development program. I threw this, how many buildings, the building in which I was taking the class will last this, nobody said more than 50 years. So this you have to realize. So unless you change according to the times, according to where the industry is changing, you will be unemployable. I mean, this is true with every profession. How fast you become outdated in the software industry or even in medical profession or even in the architectural field. If you are changed according to the latest trends and currents, then you will be in demand. Thank you.
Thank you, Dr. Benny. And for your information, Dr. Benny is my first employer. I worked with him just after completing my BE degree. And see, now anyway, God has given me a chance to be along with him and talk to you. See, ultimately what I want to tell you, like Dr. Benny was commenting, 10 years back he approached me for designing that timber frame truss. First thing what a civil engineer is needed is confidence. You should have confidence on yourself, and there are a lot of materials available across the world, not only within the Indian code and regulations. Across the world, data is very much available. Fetch it, do it for yourself, don't go back. Always try to go forward and meet the challenge, win the challenge, and go forward. Thank you. Thank you. That is the message from my side for my children.
Yeah, very fitting final words. Thank you, Professor Jaya. So as we have discussed that innovation is an intersection of the products that we use, the processes that we follow, but ultimately it is the people that count, right? So as Professor Jaya said, you need to be confident to take these solutions forward and implement this in the field. And the only way you can do that is when you align more with whatever the industry is practicing and you take those forward. See, if you look at the way the world is arranged today, what we call it today as a VUCA world. VUCA stands for volatile, uncertain, complex, and ambiguous. The world was never like this even 10 years ago, right? So today, you have geopolitics, which is taking center stage. You have natural disasters, which are taking center stage. And these are no small dimensions. These are big shifts, paradigm shifts which are happening. Okay, when you have a flood, an entire city or an entire town or an entire community is affected. When somebody makes a policy at one part of the globe, the entire globe is getting affected. So when you look at the entire world, it is so complex and it is so changing. So that is where all of you who are students today need to accept it as a challenge and an opportunity. There are going to be enough problems that you are going to deal with, and that will all be huge opportunities for all of you if you can get skilled in the right direction. And as I said, the initiative should not only come from the teaching faculty, professors, it should also come from you. Okay, and that is why the theme of the discussion or the theme of today's conference is empowering next generation engineers and architects. Thank you so much. Let's have lunch.
I now request Mr. Deepankar Bhattacharya on stage to present the memento to the moderator. Let's give him a big round of applause. Let's have a big round of applause, please. Thank you, sir. I now request the moderator to distribute the mementos to the panelists. Can we have a big round of applause? I now request the panelists and the moderator to stand for a photograph. Thank you, members. I request all of you to be seated at your seats. And with that, we'll be ending our panel discussion and a session before the pre-lunch. Now we'll be having a short EV session about the post-lunch events. Now we shall all break for lunch and let's assemble back in the auditorium